Do you want to be able to build web applications but feel confused about which videos to follow and in what order to learn more efficiently? In this video, you'll get a crash course on C#, the programming language you'll use to write code, followed by a comprehensive guide to ASP.NET Core MVC, the framework that utilizes C# to build web applications. You'll learn the most important topics for both C# and ASP.NET Core MVC, illustrated with concise examples to help you get started building web applications as quickly as possible. Chapters are available on the screen if you want to jump to specific topics of interest, but I highly recommend watching until the end to see how much your skills will grow with just this one course. Well, welcome, my name is Ireland and I'm here to help you learn C# and .NET on your own. So let's get started. C# is a popular and modern programming language developed by Microsoft, and it was first introduced in the early 2000s as part of Microsoft's .NET framework. C# is designed for building a wide range of software applications, including desktop applications, web applications, mobile apps, cloud-based services, and games. Some key features and characteristics of C# worth mentioning are the following. C# is an object-oriented programming language, which means it supports the principles of encapsulation, inheritance, and polymorphism. This allows developers to create modular and reusable code. C# includes automatic memory management through garbage collection. This feature helps developers avoid memory leaks and manage memory efficiently. C# has evolved over the years and includes many modern language features, such as support for asynchronous programming with async await, language integrated query for data manipulation, and more. While C# was initially developed for Windows, Microsoft has since created tools like .NET Core and .NET 5 and later versions to enable cross-platform development. This allows developers to build C# applications that can run on Windows, macOS, and various Linux distributions. Visual Studio is the primary IDE for C# development. It offers a powerful set of tools for coding, debugging, and designing user interfaces. Just go to visualstudio.microsoft.com. There you can install Visual Studio. You can just scroll a bit down and click here on Download Visual Studio, and you can select this community version here, which is the free version. That's how you download it. I have already downloaded it and installed it, but it's a pretty straightforward process, which I'm not gonna do in this video. But I'm just opening up Visual Studio and I'm gonna need to create a new project here. And as a template, I'm gonna select the console application here, and I'm gonna leave the rest as default. The name, I'm leaving it as it is, the name of the project. And also the version here, .NET 7. I'm going to create the project now. But as I was saying, console application is this basically this application that takes input and displays output at a command line console, which you will see in a bit. So this is the project that was created by default. And here you can see this line in this file, this console.writeLine hello world. Console.writeLine prints out this message hello world to the terminal. And if we run the application here on top, if we select run without debugging, we should see the terminal pop up with the message hello world. If you want to know what your next step is in your C#.NET developer journey, I have a free roadmap that outlines the exact steps you need to take in the right order. So whether you are a beginner who wants to become a C#.NET developer or you want to know what's next, you can get your roadmap for free at the link below. A variable is a way to store data in the computer's memory to be used later in the program. C# is a type-safe language, meaning that when variables are declared, it is necessary to define their data type. A data type specifies the size and type of variable values. We will start and see the most common data types one by one by starting with integers. To declare a variable, firstly we write the data type, then we give a name to it, and then we give it a value with the equal sign. Integer types store whole numbers, positive or negative, without decimals. As you can see on the screen, the size of an integer is 4 bytes, and you can also see the range of numbers that can be stored in them. So basically from the smallest negative number that can be written with 4 bytes to the biggest positive number that can be written with 4 bytes. We can print this value to the console using console.writeLine, and then inside the brackets we write the name of the variable that we created. If we just run the application here, we'll see the value of the variable in the terminal. Next, we have the long data type, which is usually used when int is not large enough to store the value. So we can create a long variable, just give it a name, and we'll put there a big number and make sure it should end with an L. The float and double data types can store fractional numbers. Note that you should end the value with an F for floats and D for doubles. The difference between them is that the precision of float is only 6 or 7 decimal digits, while double variables have a precision of about 15 digits. Therefore, it is safer to use double for most calculations. A Boolean data type is declared with a bool keyword and can only take the values true or false. Then there is the char data type, which is used to store a single character. The character value must be surrounded by single quotes and its size is 2 bytes. The string data type then is used to store a sequence of characters. The string value must be surrounded by double quotes and it takes a space of 2 bytes per character. Operators are used to perform operations on variables and values. The main operators in C# are arithmetic operators, assignment operators, comparison operators, and logical operators. Arithmetic operators are used to perform common mathematical operations. There are 2 types of mathematical operators, unary and binary. Unary operators perform an action with a single operand, while binary operators perform actions with 2 operands. We're going to start here with the binary operators. So firstly, let me just create a variable here, declare a variable here. So it's an integer variable. I'm naming it x and I'm giving it the value of 5. But we could also just write the type of the variable and the name of it in the first line and then give it a value underneath. So I'm just removing this here and I'm giving it a value underneath by using the binary operators. So I'm giving to the x the value of 5 plus 3, which should actually result in 8. Let me just print the value of x to the console, run it here, and we'll see the value of x to be 8. And the same thing we can do with all of the other binary operators like division, next subtraction, division, multiplication with this sign here. So 5 times 3 should be 15. And we can also use the modulo operator, which basically just gives us the remainder when we divide 5 with 3. So 5 modulo 3 would result actually in 2. Okay, so we can see it here. If we make, for example, 5 modulo 5, it's 0 because there's no remainder. We can also check here the unary operators, which are the decrement operator and the increment operator. So I'm giving to the x the value of 5 firstly, and then I'm gonna increase its value by 1 with this increment operator with 2 pluses. And we can see that the value of x was 6. And we can try now the decrement operator, which will decrease the value of 5 to 4. And we can use this in front or so before or after the x, and it wouldn't make a difference actually, as you can see. Now we will see the assignment operators, which are operators that are used to assign values to variables. We have seen this when we gave the x, when we declare a variable and we give the x the value of 5, but there are also other assignment operators, which we will see. So this plus equal operator, for example, would just add to the x the value of 6. And the same thing goes for other operators that we saw before. So minus equals will subtract from 5, 6. You can do division equal, multiply equal, or also modulo equal, which will just, for example, do the modulo of 5 with 6, which is 5. Now we'll see the comparison operators, which are used to compare two values or variables. And the return value of a comparison is either true or false, which we will see with examples now. So let me just firstly have another variable to test these comparison operators. So naming it y. And here in the brackets, when we printed a message to the console, we'll use the equal operator, which returns false in this case because x is different than 6. And if we do this, if we try to compare x with y, it would be false again. Here we can also try the greater than operator, which returns true in case x is greater than y. And in this case, this is also false. We have the less than operator. Also have less than or equal to, which returns true if x is either equal to y or less than or smaller than y. We have greater than equal or equal to also. And we can also try here the not equal to operator. So in this case, x is not equal to 6. That's why this expression here gives us true. We can try it here with different values actually. What we will see now is we will see the logical operators, which are used to determine the logic between variables or values. And just give another value to y. And here we'll try some expressions to test our logical operators. So the logical AND returns true when both expressions on the left and on the right are true. So if x is greater than 5 and y in this case is equal to 2, it will return true. But as it is the case, if only one of them is true, then this whole expression will return false. Then the logic, we have also the logical OR, which actually returns true in case only one of the statements on the left or on the right is true. So in this case, y is equal to 2. That's why this expression returns true. And the other logical operator is the logical NOT, which reverses the value of the expression. So if an expression is true, it makes it false. And if the expression is false, it makes it true. So y is actually equal to 2. That's why in this case, the value will be false. While doing different projects, you'll see that you will need to format and change the way the output is displayed to the user. So in this video, we'll see some main ways to format strings like character escape sequences, string concatenation, and string interpolation. An escape character sequence is basically an instruction that will affect the output of your string. In C#, the escape character sequence usually begins with a backslash, and we'll see some different examples here. So as usual, we'll print a string message to the console with this console.writeLine method. And here inside the string, we'll use I'm writing a message firstly like hello YouTube. And here we'll use a character escape sequence, which is the \n, which basically just inputs a new line after the hello word there. So hello and YouTube should be displayed in 2 separate lines, as we can see here. We would also use the \t, which just inputs a tab there. A tab is just like 4 spaces of just like 4 spaces. But what if we would want to write double quotation marks inside the string? Well, usually the double quotation marks mark the beginning and the end of a string, but if we would try to run the program here, it would give us actually a syntax error, as we can see here. So what we would do in this case, if we write the backslashes before the 2 double quotation marks, this would actually display the word that we need inside double quotation marks. So basically this way the program just ignores these double quotation marks and just prints them as they are. But we will see another example here. For example, if we want to print the address of a file and we would need to actually output these backslashes to the console, if we try it just like this, this would give us an error. If we try here to run the program, yeah, you can see here unrecognized escape sequence. So what we need to do here is, if we write 2 backslashes, this would actually just display a single backslash. So if we try to run the project here, we would see our string with single backslashes. Another concept we will see now is the verbatim string literal. A verbatim string literal will keep all white spaces and characters without the need to escape the backslash. So if before the string we write the @ sign, this is a verbatim string literal, which just prints everything as it is written. So it doesn't escape the backslash, the spaces are as they are written inside the string. This we can see here, everything is displayed just like we write it. Now we'll see the string concatenation, which is simply just combining 2 or more string values into a new string value using the plus operator. So firstly, I'm going to need here 2 string variables. So I'm naming it var1, variable1. I'm just writing some text. And below, another variable as well, variable2. Just writing there, I don't know, again, YouTube. That's all my creativity for the day. And here in a third variable, we want to print those 2 variables both. So in a message variable, I'm printing variable1 plus variable2, and I can also add just manually a string there. So this exclamation mark, for example, here inside the string. And if we try to display this message to the console with the console.writeLine message, let me just run the project here, and we'll see hello YouTube there. So these 2 variables are combined in one together with the exclamation mark. If we add a space there to the hello, they will be printed as we want it to be printed. But actually, usually we could also write this entire thing inside the console.writeLine method. So we actually didn't need the message variable. It's good to just like remove the additional variables if they are not needed, these intermediate variables. So we can write the variable1 plus variable2 plus exclamation mark just in the console.writeLine method. So what we're going to see now is we'll see the string interpolation, which just inputs values of variables into a string. So these variables are written inside curly braces, and the string has to begin with a $sign. So here we'll write the values of variable1 and variable2, and just some random text in the middle or at the end whenever we want, wherever we want. But this string here has to begin with a $sign. So this is string interpolation. If we try to run the project here, we'll see that the values of those variables are displayed in the console. Another thing we could do is we could combine together the string interpolation with the verbatim string literal. So here if we write after the $sign the @ sign, Here inside, if we, for example, wanted to display the backslashes, and we would like to also have like the address of the file, for example, we wanted to put it as a variable there. We can try here and write inside the curly braces the variable 1, variable 2. So the interpolation helps us put their variables inside the string, and the verbatim string literal helps us to display to the console these backslashes or everything just as they are written. So the spaces and all. And as we can see, everything is displayed to the console as we wrote it. Typecasting is the process of converting a value from one data type to another. Typecasting enables us to work with variables of different types, and it is also helpful when we want to ensure that some specific data is in the correct format for a particular operation. In this video, we will see implicit casting, explicit casting, and casting using some built-in methods. Implicit casting converts a smaller size type to a larger size type. Let's say, for example, we can take an integer, which is 4 bytes, and convert it to a double, which is 8 bytes. Let me just firstly take an integer variable here. I'm giving it a name, like my int, and a value of 9, for example. And in order for me to convert this integer into a double, I just need to assign to a double variable the value of the integer by just writing the name of the integer variable here. So this is how implicit casting is done. If I print now in the console the value of the double variable, it should be equal to 9, just like the integer variable. And explicit casting happens when we convert a larger size type to a smaller size type. For example, if we convert a double to an integer. So first, let me just declare a double variable here, and I'm giving it a value of, let's say, 8.65. Don't forget the D at the end. And in order to convert this double into an integer, before assigning it, I just need to write in front of it, in parentheses, the data type, which in this case is an integer. So this way we convert the double variable to an integer. And if I print to the console the value of the integer variable, we'll see that the value is 8. This happens because in explicit casting, the value of the double is truncated, or so to say, the part after the decimal is totally ignored, and in the integer is stored only the number 8. There is also another way to convert values from one data type to another, and this is done by some built-in methods. These methods are part of the convert class, and we will see later on what classes and methods are, but right now we just need to know what we use them for. For example, here, if in order to convert this double to an integer, I need this convert that to int 32. 32 just shows us the size of an integer in bits, and inside the parentheses, I'm taking there the value of my double, and if I print the value to the console, we see here that the value of the integer is 9. This happens because the difference of these convert methods with the explicit casting is that they don't ignore the part of the decimal, but they round the value of the double. And this results in the integer to be 9. If we try here and change the double to 8.45, we'll see that the value would be 8 now, which would be rounded again. So this is the difference of these convert methods to the explicit casting. With methods of this convert class, we have different methods to convert data types, such as convert.toInt64, which converts values to a long. An integer with 64 bits is basically a long. We can convert values to a double, to a string, or to booleans. When coding different projects, you will see the need to apply decision-making logic to them. For example, you would want to print specific message to the user or perform some action when a certain condition is met. In C#, we use conditional statements for this purpose, and this is what we will see in this tutorial. So firstly, we will see the if statement, which specifies a block of code to be executed if a certain condition is met. And we firstly need to write this if keyword here, and inside parentheses, we write an expression which should return either false or true. And inside curly braces, we write the block of code that we need to be executed in case the condition is true. So to illustrate this, I'm just taking an integer variable, naming it age, and storing a value there of 18. And inside the parentheses, I'm writing an expression with this less than operator. So if the age is less than 18, we want to print out to the console a certain message like, I don't know, you are a kid or something. And if I run the project, the age is actually not smaller than 18, not less than 18. So it should print out nothing, basically. Okay, as we can see it here. But now we'll see the else statement, which specifies a block of code to be executed if the condition is not met or the condition is false. So inside the curly braces here and after the else keyword, we write the block of code here that we want to be executed. So I'm just writing here console.writeLine, and I'm printing out to the console like, if you're not younger than 18, you're an adult. So the program firstly checks the first condition, and if that's not met, it goes to this else clause. And as we can see on the screen, it's printed out, you are an adult. After the first condition, after the if statement, we can write an else if statement, which specifies a new condition if the first condition was not met. After the first condition was false, the program goes and reads these second conditions that we write here inside parentheses after the else if keyword. So I'm just writing here something like, if age is bigger than, let's say, 65, we want a certain message to be printed out. So I'm writing the code here inside curly braces, and I'm just writing console.writeLine, and just like a message, I don't know, you are old. If we try and run the project here, the age is actually 18, so it's still printed out, you are an adult, because the first condition is not met, the second one either, and it goes to this else statement. And if we make it 65, the age, it should still print you are an adult, but if the age would be greater than 65, if the age is 66, you should see the message you are old. This way that we are using here actually is not so convenient with me changing the value of the integer. And what we can do in this case, we can use a more interactive way so that the user can input data using the terminal, and this is done by this console.readLine method. The one problem actually is that this method returns a string, which in our case, if we see the error here, cannot implicitly convert type string to int because we are storing it inside an integer variable of age. And for us to change it, to convert, we have learned typecasting in the previous video, and we can convert the value of this method to an integer with this convert to int32 method. When we input the number to the console, it will be converted from a string actually to an integer. And then it will be stored to this age variable. I'm just writing a message to the console, firstly to tell the user to enter the name, just like to make it more user-friendly. So if I run the project here, we'll see that we have the option to input data in there. So I'm inputting an age, and if I hit enter, we see that it is printed out, you are a kid. If we run the project again and try another age, yeah, 76, you are old. What we will see now is we'll see the switch statement. The switch statement we use to select one of many blocks to be executed. So we write the switch keyword, and inside parentheses we write an expression and a variable or an expression, and then inside curly braces we open the curly braces, and there we specify multiple cases. The value of the expression is compared with the values of each case, and if there is a match, the associated block of code will be executed. So here, let me just write what we wrote above. So if in case the expression or this age is less than 18, we write there semicolon, and we copy this message from above, this console.writeLine, you are a kid, to be executed. And after this code is executed, actually we need to write the break keyword afterwards. The break keyword just basically means that just breaks out of the switch statement. So if the first case is true or is a match, then the program doesn't need to read all of the other cases, but it just breaks out of the loop. It just breaks out of the switch statement with this break keyword here. And down below, we'll write the second case if the age is bigger than 65. So I just write case. In case it is the age is bigger than 65, so we just write greater than 65, since the age is specified inside the parentheses. And we write colon, and we just write this message to the console, and don't forget the break keyword. And lastly, we will write, so as we saw above this else statement, we have a similar one here. So in case none of the cases above is met, we write this default keyword here. And here we specify what we want to be executed by default. So if none of the cases above were met or were true, and we write the break keyword again to break out of the switch statement. And all this switch statement here, this code should be equal to what we wrote above. The functionality should be the same. So let me just delete it firstly and just try to run the project and to try how it works. So if I enter the age of 43, it tells me I'm an adult, as it should, according to what we wrote. If I run the project again and write 66, it tells me that I am old. Arrays are a fundamental data structure in C#, and they are used to store and manipulate collections of data. An array is basically a collection of elements of the same data type that are stored together. To declare an array, firstly we need to write the name of the data type, and then we need to write square brackets and the name of the array. That's the declaration part. And to give it a value or to initialize it, we write the equal sign. There are multiple ways, but first we will see this one. So we write the new keyword, the data type again, and inside the square brackets we write the size of the array, which is fixed. Every array has a fixed size that we specify in the beginning. And what this new keyword does is that the new keyword creates a new instance of an array in the computer's memory that in this case can hold 3 strings. Now to access each element of this array, we need to write the name of the array, and inside square brackets we access them by the indexes. Arrays begin with the index of 0, so the first element of the array is in the 0 position, and here we give it a value, a string value like John. And then to access the second element of the array, we go to the index number 1, and which is equal to, we give it a value like a string, another string like max, a name of a student, and that we can do now also for the third student, because this array has only 3 elements. So beginning from 0, and we give it the name of Paul. And if we would actually try to give a value to another student, to a fourth student, the program would give us an error because the array has only 3 elements. I'll try and run the project here. We can see that the index was outside the bounds of the array on line 7. And that's basically the error. So to print out these elements of the array, we write the console.writeLine method. And we can use string interpolation, which we saw a couple of videos back. So we write the $sign. And then inside double quotation marks, we write like some text, like the first student. And inside curly braces, we take the first student by writing the name of the array. And inside square brackets, the index of 0. And that we can do for all of the 3 elements of this array. So I'm just copying this. I'm doing the same for the second and the third student. So let me just write here second student and change the index to 1. Then the third student and change the index to 2. If I print this out, there we see first student John, second student Max, and third student is Paul. What we'll see now is another way to initialize the array. There are multiple ways, but basically you just need to know them. You can use whatever you want, but you just need to know them. So when you see it, you can recognize them. So I'm deleting that part here, and to give a value to the array, we can just write in the same line, inside curly braces, we can write the name of the strings, separated by a comma, so like John, Peter, and I don't know what the other name was, Max, and this is valid, actually. This is one way to do it, but we could also delete the first part here. That's not necessary. So just by writing the values of the strings inside curly braces, that's how we give value to the elements of the array. You can see that it works just the same way. Another way would be for us to just declare the array in the first line just like that. And then we can just initialize it down below. So student, by writing students, the name equals to this new keyword, string, name of the data type, inside curly square brackets, the size of the array, and then inside curly braces, we can write again we can give value to the elements of the array. So like John, Peter, and Max. If I run the project here, you will see that it still works. So there are different ways to declaring and initializing arrays, but you can just use one of them, whichever you want, but you need to recognize it when you see it on somebody else's code, for example. Here we will see how to reassign a value of an array. So if, for example, for the first element, we gave a value above to it, like John, we can reassign it by just accessing that element, so students in the index of 0, and giving it a value of we'll give it a surname as well, so John Baker. If I run the project here, the name was reassigned, so to say. So the first element of the array, we gave it another name. The same things when creating arrays works also for other data types. Let me just make a short example here. So if the array would be of an integer array, just need to write here int, give it another name like my numbers. It would work just the same way. And to initialize it here with my numbers equals new integer array with 3 places, and the values of the integers of the elements won't be inside double quotation marks, but just like numbers, just like integers. I'm changing it here also the way we access the elements of this array. So my numbers in the index of 1 and my numbers in the index of 2. I'm just changing the text here that it shows when we display the elements of this array. If I run the project here, we see the first number is 1, second is 3, third number is 5. So it works just the same way. Loops are used to execute a block of code as long as the specified condition is reached. We'll see how both of these loops work and the difference between them so that we know when to use each one of them. So we'll start with a while loop. The while loop loops through a block of code as long as a specified condition is true. So we can just write while, and inside parentheses, we write the condition, which is a Boolean expression that returns either true or false, and then the block of code will be written inside curly braces. To give an example, I'm just taking a variable, an integer variable, I'm giving it a value of 0, and I can int I variable equal to 0. I is actually an abbreviation for the index in programming, but it doesn't really matter how you name the variable. And then let's make the condition to be true when, let's say, the variable is less than 11. And then inside the curly braces, we want to print out to the console with this console.writeLine method the value of the variable. And in the end of the iteration, we want to increment this value, the value of the variable, by 1 by using the increment operator. So just by writing I plus plus. So how this works is that in the first iteration, the value of the variable is 0. So the condition is true, and because of this, the value of the variable will be printed out to the console. And then, in the end, the value of it will be incremented by 1. In the second iteration, the value of the variable is 1, so the condition is again true, and the block of code will be executed again. This will happen until the value of the variable will get to 11. In this case, the condition will be false, so the program will just skip the loop. If we just run the program here, we should see a list of numbers from 0 to 10, which is basically what this code that we wrote here does. When we write a while loop, we should always make sure that its condition will be false at some point. Otherwise, if the condition of the loop is always true, the program would run the block of code forever, and this would result in an infinite loop, which we do not want. So in our loop here, if we didn't increment the value of the variable after each iteration, its value would always be 0, and the program would run the value of 0 over and over again. As we can see here, the program would run the 0 value just like over and over again, the value of the variable, and this is an infinite loop. Infinite loops would just cause our program to crash at some point, and we do not want that. To avoid it, we should either take care of the logic of the loop, or we could also use the if statements so that when a certain condition is met, we want the program to just break out of the loop. Let me just change the logic here of our loop a bit so that we can make use of this if statement. So let's say we want to run this code as long as the variable I is greater than or equal to 0. So let me just remove this, just greater than or equal to 0. And in this case, this would actually be an infinite loop, since we would just increment the value of the variable after each iteration, and the condition would always just be true. And to stop this, we can just make an if statement so that when the variable reaches a certain value, just like, let's say, 15, we want the program to break out of the loop by just writing inside curly braces this break keyword, which we also saw when we saw the switch statements. This just makes the program to break out of the loop. And if we run the project here, we'll see a list of numbers from 0 to 15. When the variable reaches 15, the program will just break out of the loop. And what we'll see now is we'll see the do-while loop. The do-while loop is just like a variation of the while loop, but what it does is that the program just executes the block of code firstly, and then iterates the condition. So I'm just writing here the same logic of the while loop that we did before. So I'm just printing out to the console the variable value, and then I'm incrementing its value. And underneath, we write the condition. So while the variable is less than 11, let's make it again so. And in this case, we would still see the same result. We would still see a list of numbers from 0 to 15, from 0 to 10. But in other cases, for example, if we want the condition to be true when the integer is greater than 5, even though the condition is false in this case, the program would still just run the block of code once. And then when it checks that the condition is false, it will just like skip the loop. So we should use the do-while loop instead of the while loop in those cases when we want to execute the block of code at least once, no matter of the condition. The for loop iterates through a block of code for a specific number of times. And this level of control makes the for loop different from the other iteration loops. We will see its structure in this video, how to use it, and of course, a few examples. Firstly, we write the for keyword, and then inside parentheses, we write there are three different parts separated by a semicolon. Firstly, we initialize the iterator variable that we're going to use for this loop. Here I'm taking an integer variable, naming it I, and giving it an initial value of 0. And after this, we write the condition. As long as this condition is true, the block of code that we will write below would be repeated on a loop. And in the end, we write the iterator, which basically determines what will happen after each iteration. Here we're incrementing the value of I by 1. And inside the curly braces is written the block of code that should be repeated on a loop. Let's say, for example, we will print out for each iteration with this console.write line the value of this I variable. We should be able to see a list of numbers from 0 to 9. When the variable is 10, the condition will no longer be true and the program will skip the loop. We can actually play around here with the conditions and the iterator. We can also decrement the value of the I variable after each iteration. And let me just say here, we'll start by a value of 10, and the condition will be true as long as the variable is greater than or equal to 0. So this basically is the reversed thing. We'll see a list of numbers from 10 to 0. And would also decrement the value of I after each iteration by more than 1, by let's say by 3, by writing this minus equal operator that we have learned. So I minus equal 3. We'll see then printed out 10, then 7, then 4, and then the number 1. Many different mathematical problems can be solved with the for loop. Let's say, for example, we want some specific information from a list of 100 numbers. Let's say I'm changing this again, so I'm taking numbers from 0 to 100, and I'm incrementing the value of I after each iteration. And let's say, for example, we can use an if statement inside the for loop to get some specific information. So let's say if we want numbers that can be divided by 4, we can write here I modulo 4 equals to 0. So if this condition is true, then the number can be divided with no rest, and we'll just set the curly braces. We can print out to the console these numbers, and I'm just starting from 1, so the 0 does not count, so that the 0 won't count. And we here have numbers from 4, 8, 12 until 100, all the numbers that can be divided with 4. Another important use of the for loop is that we can use it to iterate through the elements of an array. So let me just have an array here of characters. I'm writing here char, and this square brackets, I'm naming it grades, and I'm giving here values to the elements of the array. So I'm just inside single quotation marks, I'm writing the grades A, B, C until F. And for us to iterate through each element of this array, I'm using a for loop. I'm starting from the value of 0. I'm initializing here the I variable. The initial value will be 0. And for us to loop through each element of the array, I'm going to need to make the condition true as long as I is less than the length of the array. We can take the length of the array by using grades.length. .length is a method that we can use with each array, which we'll learn later what methods are actually, but just for now we need to know what it does. So this loop will be true as long as I is less than 6 in our case. And after each iteration, we'll increment the value of I. So to get access to each element of the array, let me just print out to the console. We'll access the element of the array by writing the name, grades, and then inside square brackets, the position of the element at the array. So in the first iteration, we'll be printed out the element in the 0 with the index of 0. And then in the second one, the element with the index 1, and so on until the last element of the array. If I run the project here, we'll see a list of all of the elements of this array. We could also use this for loop to manipulate data inside the array by just accessing the array, the elements of the arrays, just like we did here. But this was just an example. In the previous video, we saw the for loop in C# and how we could iterate the elements of an array with it, which we can see in this code here as well. But there's also another loop used exclusively to loop through elements of an array, and this is the foreach loop. This is what we'll see in this video, how the foreach loop works, but we'll also see the limitation that it has when compared to the for loop. The foreach loop provides a simple and a clean way to loop through the elements of an array. Firstly, I'm just going to comment this for loop here out by just writing Ctrl plus K plus C in the keyboard at the same time, so that we just have it in the background as a reference. And underneath, we are going to start to write the for each loop. Firstly, we just need to write the for each keyword. And then inside parentheses, we need to specify a temporary variable, which will have the type of the elements of the array, which is chars in this case. We will give a name to this temporary variable, and then we write the in keyword, and then the name of the array that we are looping through. Basically, this temporary variable holds the value of the element associated with the current iteration. In the first iteration, the grade variable holds the value of the first element of the array, or the value of the letter A in our case, and so on. And what this for each loop does is that it takes each element of the array, starting from the first one and then in increasing order, and for each one of them it executes the block of code that we will write below. So here inside curly braces, we will write this console.writeLine method, and we'll print out to the console each element of the array by just writing grade, this temporary variable grade there. And what this code will do is we'll do the same thing as the for loop did before, so it will print out to the console each element of our array. We will do different things with the for each loop. I'm just taking an integer array below so that we will do some different things with integers. I'm just taking an integer array, naming it my numbers, and I'm giving some value to the elements of this array, like 30, 55, 66, I don't know, 78. And I'm going to need also another variable here down below, an integer variable. I'm naming it sum, and I'm giving it a value of 0 at first. Then we'll write the for each loop here. I'm going to declare a temporary variable of integers, which is the type of the elements of the array. I'm naming it number, this in keyword, and the name of the array that we're looping through. So inside curly braces here, in each iteration, I want to add to the sum variable the value of the current element of the array by writing here this number variable. So at the end, this sum variable will have the sum of all of the elements of our array. And after the loop ends here, I'm just gonna need to print out to the console this sum variable so that we will see what value it will have if I run the program here. Here at the end, we see 229, which is the sum of all of these elements. Just gonna delete this part here, and what we'll see now is we will see the difference between the for each loop and the for loop, or the one limitation that the for each loop has. If you would want, for example, to reassign a value in this array of elements inside the for each loop, I'm just using here an if statement. So in case the element, this grade variable, is equal to, let's say, a, the letter A, inside curly braces here, we can reassign it. We'll try to reassign this grade, this element of the array, with another letter that we haven't used before, let's say Z, and we see that there's an error there. If I run the program, we'll also see the error here. So cannot assign to grade because it is a for each iteration variable. And this is actually for every for each loop, we cannot reassign or modify the elements of that array inside the for each loop. But what would happen if we would try to do this inside the for loop above? I'm just uncommenting this out by clicking Ctrl + K + U in the keyboard at the same time. And here I'm just going to try to copy this code here. Inside the for loop, I'm just going to need to change the name or access the elements of the array by just writing here grades, the name of the array, and we'll access the elements of it by writing square brackets and this I variable, this index of the elements. And inside the for each loop below, I'm just gonna use it to print out to the console the grades, each element of the array, by just writing console.writeLine grade. So the first loop would just reassign the value of A to Z, and the second loop, the for each loop, will just print out to the console each element of the array. And as we can see here, the elements of the array are printed out to the console, and Z is the A element, the first element is reassigned to Z. So these two loops are very similar with each other. In some cases, the for each loop is the better choice since the code is cleaner and shorter, but depending on each case, as you saw here, you should use the for loop if you want to modify the content of the array. A method is just a unit of code designed to perform a specific task. Methods are also called functions, and they are a key part of keeping the code structured, efficient, and readable. So firstly, when writing a method, we need to start by writing the method signature. The method signature starts by writing the return value of the method. Void is the return value when the method doesn't return a specific data. So the method may print something out of the console or do some specific task, but it will not return a specific data type. And then we write the name of the method, which basically tells us what the method does. In C#, the name of the method is written using Pascal case. Pascal case is this naming convention where the first letter of each compound word is capitalized. If we were using camel case, the first word would be in lowercase. And then we write the parentheses, and inside curly braces, we write the definition of the method, which is basically what the method does. And in this case, I'm just writing something out. I'm just printing something out to the console with this console.writeLine method. Just something like hello, for example. And this is how we write the method, but if we would run the project here, we would not see anything printed out to the console. For a method to be executed, we need to call it. This we can do before or after we define the method, and how we do it is by just writing the method name and the parentheses. And of course, after that, this semicolon. If I run the program now, we should see hello printed out to the console. Sometimes the method may need to get some information into it, so we need to input some data in the method. And how we do it is by writing parameters in the method. So inside the parentheses, we define firstly the data type that the method needs to get, and then like string, and then we give a name to it. Basically just like variables. I'm just going to use this variable here when we print the message out to the console by just writing plus here and the same variable and the value. And the value of this parameter is specified by us when we call the method. Here inside this print name line here, inside the parentheses, we need to write a string. And what this is called an argument. So the value we give for the parameter when we call the method. Like Ben or something. And if I run the program here, we should see hello Ben in the console. A method can have multiple parameters. Let me just have an integer here as well. I'm naming it, I don't know, like age. And I will just change a bit what we print out of the console. So it's like a sentence, like name, plus a string like is, plus this age variable. And this, now we also need to specify an integer argument when we call the method. Some value like 21 or so. If I run the program here, we should see Ben is 21. What we'll see now is we'll see what default parameters are. So sometimes when we can give to a parameter a default value. Let's say, for example, we're handling here people of an age like 21, and we can give it the parameter here with an equal sign. We can give it a default value. So in this case, we do not have to specify the age variable when we call the method. We don't need this as an argument. And if I run the program now, we should see Ben is 21. So the age is by default 21. But if we would want to change the default value of it, we can just input here when we call the method another value. And the age now will have the value of 30. We'll see also now the named arguments. When we call the method, if we do not specify the arguments in the correct order, it wouldn't work. Let's say we define first an int argument and then a string argument. The order is not correct. But if we do not want to remember it, we can specify it manually here to which parameter it relates to with these key value pairs like age, colon, and then 30. And we can do the same thing for this other argument, so the name of the variable, colon, and then the string. So by using these named arguments, we don't have to memorize which parameters comes first or second, and we can just specify them manually there. I'm just going to delete this part here. And until now, as we saw, we have only handled void methods that do not return a specific value. But methods can return different values, like integer, double, boolean, or something, or anything. And we'll do this by writing int, firstly, in the method signature, and then the name of the method. I'm just having two integer parameters here. And inside the curly braces, let me just return x plus y. So this method returns an integer, which is the sum of the two parameters. I would call the method here, this get sum and two integers. If I run the program, we shouldn't see anything actually in the console because this method only returns a value. It doesn't print it out of the console. And how you can see its value is either by writing this getSum method inside the console.writeLine method, but usually for the code to be more readable, we usually store the value of the method inside another variable. Let me just delete this. I'm creating a result integer variable, and then I can simply just print out to the console this result variable. It's more easy on the eye and you understand what you are doing better. I'll delete these lines here. So let me just define here a string method which returns a string. I'm naming it getName. I'm just giving it a string parameter here of name. And I'm just making the method only to return this name. And for us to actually see what the method returns, I'm just creating a variable here to store what the method returns, like a string result variable. And we write here the method, we call the method here with this getName, and we need a string as an argument, like Kim. If we just print out this variable now to the console, should be able to only see this name, the string that the method returns. So these were the basics of methods in C#, the main concepts and terms that you would need while working with them. We will also see methods later on as members of classes, but this was it for now. As we have talked about before in this series, C# is an object-oriented programming language, which basically means that the data and behavior are organized in reusable data structures called objects. Today, we're going to talk about classes and objects, which are the two main aspects of object-oriented programming. In C#, a class is a blueprint or template for creating objects. It defines the data and behavior of the objects that will be created based on it. In simpler terms, a class is like a blueprint for a house, where the house represents an object, and the blueprint defines the structure and behavior of that house. So here I have just created a simple console application in a Visual Studio. Here you can see a program class with a main method inside of it. What this main method is the main method is the entry point of a console application. As soon as the program starts, this is the first method to be invoked, and we use this main method to actually create. This is the place where we create the objects after we have created the class. The main method is usually stored in a separate class, or so to say in a specific class, and we name it program by convention. And actually, I will start this tutorial by creating firstly a class. Above it, to create a class, we write firstly the class keyword, and then we give a name to the class. I'm naming it user, and then inside curly braces we define the class. A class has fields and methods. What fields are like variables inside the class, and what they do is they define the property, so to say, they define the data or the property of the class. Let me just take an example here. The first field, I'm gonna have a name field, writing here public string, and I'm giving it a name of name. So what this public keyword here does is this is an access modifier that basically allows us to access this field of the user inside other classes. And then I will actually make a specific video about access modifiers so that you won't get overwhelmed in this video, but just so that you know what it does. And then we write the data type and a name for the field. I'm actually going to go ahead and create another field. I'm naming a string, and I'm naming it username. In Pascal case, that's how you write it. And now I'm also going to create a method. Methods basically just define the behavior of a class. I've also made a separate video about methods. Just a couple videos before this. I think I will link that down in the description. But yeah, let me just create a method firstly. I'm making it public so that it can be accessed outside this class, just as I did for the fields. And then we write the return type, which I'm gonna set it to be void, so that it doesn't return a specific data type. Then I'm giving it a name. I'm naming it get user, then parentheses, and inside curly braces here, I'm just gonna print out to the console. Let me see. Okay, I'm gonna print out to the console this name and username fields. So like this string interpolation, this is how we access the fields. Name, and don't forget the semicolon here. So here we have created our class, and down in the main method we can create objects which are instances of classes. So to create an object, firstly the syntax of it is, firstly we write the name of the class, and then we give a name to the object. I'm naming it first user, and then equal, write the new keyword user, which is again the name of the class, and then parentheses. This is how you create an object. And then to access the fields and the methods of this object, which it inherits from the class, we just write here the name of the object dot, let's say name, the name of the field, and we can give it a value here to it. Let's say Sean. And just the same way, we can also access the second field, the username. Okay, this is first user was the name of the object. We can give a value to the username, let's say Sean.Baker. And lastly, what I'm gonna do is I'm gonna also invoke the method, the getUser method that this object inherits, by just writing first user dot get user and then parentheses. And what this will do is actually it will just print out to the console the name and the field, the name and the username of this object. So if I run the program here, we should actually see Sean, Sean.Baker. We can create as many objects as we want. Let me just copy this down. I'm creating a second object. I'm naming it second user. Okay, I don't know what I did here. Then I'm giving it another name like John. User. And then here I'm accessing the username field. I'm making it like John.Baker, the username. And then I'm calling this method that this second object inherits as well. So if I run the program again, we will see for the two of our objects this method invoked. So let me just go back to our code here and to our class more specifically. We saw before class members that we have fields and methods, and it's also important to know that there are two types of class members. We have instance members and static members. Instance members are those members that are accessible from an object. As we saw in this example here, we firstly needed to create an object, and then we access the fields of the class and also the method. But we also have static members. Static members are accessible by the class itself. Let me just take an example here. I'm just making a static method. For us to do it, after writing public here, I need to write the static keyword. I'm making the return type to be void. I'm giving it a name. I know I'm just printing something out of the console. So I'm just writing here print. And here I write console.writeLine. And I'm just printing out this is a static method. Just like that. And for me to access this method, I don't need to access it by an object. I only need to write the class name, dot, and then the name of the method. Let me just put this at the end. If I run the program, we should be able to see this is a static method. We can also have, of course, static fields. Let me just take an example of it. So writing public static int age, and I'm just giving it here a value, and we can access this value just by using the class name. So by using user.age, this is the way we access it. And for us to see this in the console, I'm just using this console.writeLine method. If I run the program, we should see 22 at the end. We have actually seen static methods before. So just here, we can see console is a class, the name of the class, and writeLine is the name of the method, which is static, because this is how we access this method, by just using the class name. Usually, static members are defined in those cases when something is singleton. Let's say in our console application, there's only one console, and for this reason, there wouldn't make sense for there to be different objects to tell you, for example, different ways of how you can print something out to the console. For this reason, the console class and all its methods or members are defined as static. A constructor is like a special method that is used to initialize objects. A constructor is called when an object of a class is created, and the reason we use it is to set initial values for fields. So here I have just opened up a console application in Visual Studio. I just have a user class here with 3 fields, with a name, username, and age field. I also have a program class with this main method where we're actually going to create the objects. So to actually write the constructor, we firstly need to just write this access modifier. I'm setting it to public so that the constructor will be accessible outside of the user class. And then we need to write the name of the class. The constructor has to have the name of the class, and it doesn't return anything like a void or an integer or string. The constructor does not have a return type. After the name of the constructor here, we just write parentheses, and then inside curly braces we can give an initial value to a field. Let me just give here to the name field a value of Jake, and down below in this program class, in the main method, I'm just going to create a user object. I'm naming it user, new user. So here the constructor will be called and the name field will be given the value of Jake. Let me just print out to the console here with this console.writeLine method the value of the user object.name. We should be able to see Jake printed out to the console. Here we can see Jake. So even when we do not explicitly create the constructor, as soon as an object is created, a constructor is created by default. But if we do not create a constructor, we will not be able to set an initial value to the fields of the object. The constructors can actually take one or multiple parameters. Let me just, for example, here take a string parameter for the name, also a string parameter for the username, and a string and an integer parameter for the age. And down below, I'm just going to give to the field, to the name field of the class, I'm going to give the value of this name parameter. And also, I'm going to do the same thing for the username field and for the age field. And as soon as we create the object down below, we actually need to specify here. We see that we have an error here. We need to specify the parameters that the constructor has. So we need to specify a value here for the name. Let me just write it again, Jake here. We need to specify a value for the username, like Jake Baker, and also a value for the age. Let me just set it to 24. And this way, when the object is created, the constructor here is called, and it takes these 3 values and it sets this values to this name, username, and the age field. We could actually just print out to the console the user.name, or we could also then just run the program here. We could also just do the same for the username and the age. Then we just run the program one more time, and we see here Jake Baker, and the age, which is 24. So let's say, for example, we didn't use a constructor. Let me just comment the constructor out here, and also these lines of code here. The way to set the initial values of the fields of the object would be a bit different. So let me just create the same object here. And if I would want to give a value to each of its fields, I would need to do this one by one. So by setting to user.name a value like John, and then the same thing for user.username like John Baker, and then also I would need to set separately the value of the age, setting it to 24 again. And actually this way, as you can see here, it uses more lines of code, but the most important thing is that it's not actually the recommended way. It's more compact and more readable if we actually give the initial values of the fields of the object in the constructor, and then we declare it here down below. And this is actually the way you will see most while programming, the way you will actually use the most. In C#, access modifiers are keywords used to specify the visibility or accessibility of types like classes, interfaces, and members such as fields, methods, and properties. In C#, there are 6 access modifiers. The ones we will use the most are public, private, and protected, but we also have internal, protected internal, and private protected. The public keyword is an access modifier for types and type members. Public access is the most permissive access level. There are no restrictions on accessing public types or members. We can see in this code here that the public name field can be easily accessed inside another class. The private keyword is a member access modifier. Private access is the least permissive access level. All private members are accessible only within the body of the class in which they are declared. In this code here, we can see that the private name field is accessed inside the main method, which is possible only because this method is inside the same class where the field is declared. The protected keyword is a member access modifier. A protected member is accessible within its class and by derived class instances. We will see derived or child classes when we see inheritance, but basically this is a class that inherits from another class. The protected name field here is accessed inside the student class, which inherits from the user class. This colon symbol is the symbol used to make a class inherit from another one. With the internal access modifier, the type or member can be accessed by any code in the same assembly, but not from another assembly. An assembly is a .dll or .exe file created by compiling one or more CS files in a single compilation. So, in other words, internal types or members can be accessed from code that is part of the same compilation. We can see in this example here that the internal field can only be accessed inside the same assembly. The protected internal keyword combination is a member access modifier. A protected internal member can be accessed by any code in the assembly in which it is declared, or from within a derived class in another assembly. The protected internal field in this example can be accessed inside the derived class in another assembly. The private protected keyword combination is a member access modifier. A private protected member is accessible by types derived from the containing class, but only within its containing assembly. The derived class in this example here can access the myValue field only because they belong to the same assembly. These were the 6 access modifiers in C#. They are very important because they help in encapsulating and organizing the code, providing control over the visibility and accessibility of the data of our application. We saw in the previous video that private variables or fields can only be accessed within the same class. An outside class has no access to them. Well, sometimes we need to access them, and this is why we use properties. So in this piece of code here, we can firstly see a private name field, and just underneath we see a name property. A property is basically like a combination of a variable and a method, and it has 2 methods, the get and the set method. A property is associated to a certain field, in this case to this name field above, and they usually have, it's a good practice that the property and the field have the same name, but the properties should start with an uppercase letter. And this name property here, we can see that it has a get method, which makes it possible to get the name field outside of this class. And this set method makes it possible to assign a value to this name field still outside this class, since we have here a private name field. And just to see how this works, let's just go down below to this program class, to this main method. Let me just firstly create a user object, which is the name of the class, naming it object. And then we can by just writing object.name, so by using this name property, we can set a value to this. We can set a value to the name field. Let me just write just a string here, like Jake. And underneath, by using firstly the console.writeLine method, we can see here how we can access the field by just writing object.name. And if I run the program here, we should see name printed the Jake printed out to the console. So basically, by using the name property, we firstly here assign a value to the name field, and underneath here we can access the name field's value. There's also another way how we can just write all these lines of code, and this is by using auto-implemented properties. Let me just comment this out here. And to use the auto-implemented properties, this is just basically like a shorter way how to write all this code, where we do not need to specify the field here, and we do not need to specify the methods. So basically, by just writing here public string name, and then inside curly braces, I'm just going to need to write get and set. And this basically does everything that these lines here do. So this is called an auto-implemented property, and the lines below just work the same way. And we can just we can access the name field by the same way, and we can assign a new value to it just like we did before. If I run the program here, it should still work. And there's also we also have the option, for example, if we want the field to only be readable outside of the class, we can just write the get keyword here. So this name field is read only. We can only get its value outside of the class, but we cannot modify it. If we can see here where we try to change the name's value, we see an error because the property is read only, but we still have the option here to access the value of this private field. So these were properties in C#. They are important for the encapsulation of our application since they hide sensitive or certain data from the users. Inheritance is a fundamental concept in object-oriented programming that allows a class to inherit properties and behaviors from another class. The class being inherited from is called the base class, or the parent class, and the class that inherits is called the derived class, or the child class. So in this example here, we firstly have a person class with a couple of fields, with the name and the last name field, and with an introduce method that just prints out to the console this name and this last name. If we would want to inherit from this class, let me just make an example here. I'm creating a user class, and for it to inherit from the person class, I'm just gonna write the colon symbol and then the name of the class. So in this case, person is the base class or the parent class, and user is the derived class or the child class. And the user class now will inherit every field, property, or method, so all of the class members that this person class, that this base class has. So let me just open up the curly braces here, and I'm also going to add another field to this user class. I could have added as many fields, properties, or methods as I wanted to here, but I'm just going to make this example with just an additional field. I'm naming it username. And now to test out how this actually works, let me just create a user object down below in this class, in this program class, in this main method here. So let me just create a user object, naming it user, new user. And then this user object will actually have a name, which it inherits from the person class. I'm just naming it, giving it a value of Jordan. The object also has a last name, giving it a value of like Parker, and the username, of course, which is the field defined in the user class. I'm giving it a value like Jordan underline Parker. And for me to actually access also this introduce method that was inherited from the person class, I can just write user.introduce and then the parentheses. And now if I just run the application here, we should just see this introduce method get called, and we see Jordan Parker, the name and the last name of our object. Let me just also print out to the console the username. We're just writing console.writeLine and then user.username. And we can see underneath here, we see Jordan Parker, which was the username that we gave to our user object. If we would want, for example, to have another class down below that I'm naming it admin, and this actually would inherit from the user class. This class now would have all of the class members of the user class, and then as a result also all of the class members, all of the fields, properties, and methods of this person class. And I think you understand how this then works. So this was it for inheritance in C#. Inheritance is a powerful concept that enables code reusability and helps in creating a logical hierarchy of classes. Polymorphism is one of the three fundamental principles of object-oriented programming after encapsulation and inheritance, which we have seen so far. Polymorphism is a Greek word that means many forms, and it occurs when we have many classes that are related to each other by inheritance. For example, an object of the programmer class is first of all a programmer, but it is also an employee and it is a person as well. So basically it has different forms. So in this piece of code here we have a base class, an employee class with just a simple introduce method that just prints this line out in the console. And then we have three other classes that inherit the employee class. We have the programmer class, the doctor class, and the lawyer class. As we saw in the previous video when we talked about inheritance, when a class inherits from another class, it inherits all of its members. So in this case, for example, when we create a programmer object, it would inherit this introduce method by default. Let me just demonstrate it real quick. So I have a programmer object here, and if I call from this programmer object the introduce method, let me just run the program, we would see this line I'm an employee printed out to the console. But polymorphism allows us to override the class members of the base class in the derived class. So if we would want to, we have the option to change a method or another class member to be different in each specific class. Let's say, for example, we would want in each of these classes the introduce method to print out of the console something more specific. And to do so, we need to just write the virtual keyword in the method in the base class so that we can overwrite it down below in the derived classes. Then here in the programmer class, let's say, if I'm just gonna want to override the same method, I'm just gonna need to write public, and then the override keyword, the return type, and the name of the method should remain the same. And I just need to print out to the console the different message. So let's say I want to print out I am a programmer. And I can actually do this for all of the other derived classes as well. I can just change it here. I'm a doctor, the message that we want to be shown up. And in the last class, let's say I am a lawyer. So if I would actually just create an object for each of our classes here, for the doctor class, naming it doctor equals to new doctor, and then for the lawyer class, I'm creating another object equals to new lawyer. I can actually call the introduce method now for each of the objects that I created, for the doctor object and for the lawyer object as well. If I run the program, we should now see the different message printed out to the console for each of the objects. Just remember that overriding works with methods and properties by just writing the virtual keyword in the base class, but it does not work with fields. Abstraction is a fundamental concept in object-oriented programming. Abstraction involves creating abstract representations of real-world objects, emphasizing the essential features while hiding the non-essential details. In C#, abstraction is achieved through the use of abstract classes, interfaces, and abstract members, which we are going to see in this video. So firstly, I'm going to start with abstract classes. Abstract classes are classes that cannot be instantiated on their own, and they can implement abstract methods or even concrete methods, or basically normal methods that have a body in them. Let us just start creating an abstract class. So firstly, we need to write the abstract keyword, then we write class, and we give a name to this class, like employee. Let me just open up the curly braces. And here in the body, an abstract class can have fields. Let me just take an example, string name. It can also have properties like public string. Let's make the last name a property. Just write here the get and set keyword. And yeah, it's important to note that in the abstract classes, as I said before, we can have abstract methods, which are methods where they are implemented on the class that inherits this abstract class, but we also can have normal methods or concrete methods. Let me just write an abstract class in the beginning. Let's just say public abstract void, and then I'm gonna write the name of the method, like job title. I'm gonna write the parentheses, and then I'm not gonna write a body to this method. Just note that here I have written, before we write the return type for the method, I have written this abstract keyword. And down below, then just write a concrete method or like a normal method, like public void, which is the return type. And then I'm naming it introduce. And inside the curly braces, I'm just gonna print a line in the console.writeLine, like I am an employee. So, and yes, that was it. So as we can see here, we have the right to use access modifiers in the members of our abstract class. If we wanted to, we could make like the name as private, protect it, or whatever we wanted to do here. As we have seen also in the previous videos how the access modifiers work. But for now, we are going to see how we can inherit an abstract class in another class. So let me just write a programmer class, and I'm going to inherit with the colon symbol the employee class. And here, this class needs to implement the abstract method if we want to use it. So I'm just going to need to write public override. I'm going to need to write the override keyword so that we can implement our job title method. Void is the return type, and then job title. And let me just write another line here. So like console.writeLine, and I'm gonna want to print out of the console the line I am a programmer, let's say. So this programmer class inherits the name, the last name property, the name field. This job title method is implemented here, and it also inherits the introduce method, which we do not need to implement down below. Let me just go back to the program. Go here down below to the program class, to this main method. I'm just going to need to create a programmer object. I'm naming it programmer, new programmer. I'm going to see that we can use with this programmer object both of the methods, so the job title method and the introduce method. And let me just run program. And we can see firstly, I am a programmer, and then I am an employee. So now let's just see how interfaces work. Let me just create an interface firstly. By creating an interface, I'm just going to need to write the interface keyword. And then usually we can give a name to the interface, and it usually begins with an I. Let me just give it a name of employer, let's say. Open up the curly braces. So an interface is a completely abstract type, and we can only write method signatures in an interface. We cannot implement them. Here we cannot have also fields, but we can have only properties and methods. If I would want to like create a field, like a string name, it would give me an error because interfaces cannot contain fields, and we also cannot use the access modifiers that we could use in the abstract method above. So we cannot write, every member of the interface is by default public, and we cannot make it, let's say, private, protected, or we cannot put any other access modifier there. So let me just make it a property, not a field. We'll see that we won't get an error anymore. And we don't need this semicolon at the end. And we can write, as I said before, we cannot implement methods here, but we can only write method signatures. A method signature is written only by writing the return type, let's say void. And then let's write introduce here, the name of the method, the parentheses, and that's it. We're going to need to implement this method in the class that inherits the interface. If I would want to make it private, let's say the method, it would give us an error because, as I said, every member of an interface is by default public. So let me just remove this here. And for us to implement, to inherit this interface. Let me just create another class. Let's say manager to inherit the interface. I employer. And here I'm going to need to write again the property. So I'm just going to make it public here since we are in a class, not an interface. I'm going to make the property to be visible. And I'm going to also implement the method. I'm making it public, introduce, and here we're going to define a body for this introduce method. So I'm just printing out to the console with console.writeLine method. I am an employer. If I'm going down to the program class, to the main method, let me just create an object for the manager, like manager, naming it manager, equals to new manager. Here I'm calling the introduce method. If I run the program, let me just see what error I did. Okay, this should be a semicolon. We should see at the end, I am an employer. And we saw the differences that there are between an interface and an abstract class, but another difference is that a class can inherit only one abstract class. So it's not possible to inherit more than one, but a class can inherit multiple interfaces. Let's say if we had another interface here, I'm just going to create one just as an example. I'm going to give it another name, second interface. I know some name there. I'm going to delete this. Here in the manager class, we saw that it inherited the iEmployer interface, but by writing like a comma, and then the name of the second interface, this class now has the possibility to inherit more than one interface. And that's also one of the difference between the interface and an abstract class. In C#, a list is a data structure which stores collections of data. We have seen before a similar data structure, which were arrays, and a list is similar to an array, except for the fact that it can grow or shrink dynamically in size. For this reason, lists are more versatile and widely used in C#. They provide a variety of methods to work with their elements, and this is what we will see in this video. So when we talked about arrays, we saw that this is a syntax how we can create an array. Here we have the data type of the elements of the array, then the square brackets. Here we write the name of the array, and then we write the new keyword, the data type again, and then inside the square brackets, here we define the size of the array, meaning that this array can contain only 3 items. And here's a way we can access those elements. Here we are giving to each element a value, to the first element, to the second element, and to the third element. And let me just print out the elements of the array to the console by using a foreach loop. So foreach parentheses, here I'm going to take a variable of a string variable, naming it item in items. So basically what this is doing is just looping through each item in this items array. And opening up the curly braces, and I will print out to the console each item. So let me just run the program here. And here we have all of the elements of our array. So the syntax actually to create a list is a bit different. Let me just comment this out firstly. So to create a list, firstly, we need to write the list keyword. Then inside this angle brackets here, we write data type, or the type of the elements that this list will contain. So let me just create a list of strings. I'm naming it languages. And then here I'm going to write the new keyword list. We're creating a new list. Again, here we'll specify the data type of the elements of the list, and here I'm just writing the parentheses. So basically, this is the syntax of how we can create a list. And as you can see, we do not specify the size of the list as we did with the arrays. And actually, to add elements to this list, we need to write languages or the name of the list, and there is a built-in method that we can use for lists, which is add, and this method basically just allows us to add elements. So I'm adding a string element, I'm giving it a value of, let's say, Python. So basically this line here substitutes the way that we used here to add values to the elements of the array. And let me just copy this. And I'm storing also a couple other elements in the array, so I'm storing there another programming language like Java and C#, since this is a C# tutorial. And I'm still using this for each loop to loop through the elements of the list as well. So I'm just gonna need to modify it here. So language, the name of the variable in languages. So we're looping through each element of the list, and we'll print out to the console each element of our list. Okay, this is my typing error. Okay, let me run the program. And we should see here Python, Java, and C#. There are many different built-in methods that we can use to store, to manipulate, or to access our elements of the list. And let me just show you a couple of those. So if we write the name of the list again, dot, here we see a whole list of built-in methods that we can use to access or to manipulate, to do some specific operation to our items of our list. And let me just show you how the remove method works. So basically here we can specify the name or the value of the item that we want to delete from the list. So let's say we want to remove the Java from our languages list. And if we print out, if I run the program now, when we print out the elements of the list to the console, we see only Python and C#. Let me just comment this out for the moment. And we also have a method, which is the insert method, which allows us to input a specific element at a specific position at the list. Let's say we want to input in the element with the index of 1, some specific element. And let's say, for example, SQL, another language. So here, this SQL language will be put into the second item of our list. Here, momentarily, we have Java written there, but let's see what happens when we run the application. We'll see that SQL now is in the second position, or in the position with the index of 1 in our list. And then Java is pushed through the third position, and C# is pushed into the last position of our list. There are many, many more methods that we can use to play around with lists. Let me just comment this out again. And we have a method that basically, the sort method that basically just sorts the elements of our list alphabetically. Let's see what we'll have here. We have here C# because it begins with a C, then Java, then Python. Some other useful methods that you could use while coding. Let's say we have the count method, which basically just counts the number of items that the list has. Maybe here we can see that our list has only 3 items, but in a larger list or in a list that maybe is written in another file, if we want to access the number of the items that this list has, we can just write this count method, and so that we can see it, print it out. Let me just write the write line method. And we see here 3 printed out. So we have 3 elements in this array. can actually also see the index of a specific element of the array, let's say. So if we would want to know in which index is the element with the value Java, let's say, or let's say C#, by just writing this index of method, we will see that we will see printed out of the console that C# is placed in the index of 2, so in the third position basically. So these were lists in C#. As we saw, the main difference between a list and an array is that lists can grow or shrink in size, and we saw a few methods that we can use to work with lists. A dictionary is a data structure that allows you to store and retrieve values based on unique keys. This concept can be compared to a real-world dictionary. So consider the dictionary of the English language. Each word in the English language serves as a unique key. Keys are used to look up the definitions of words, and the definitions of the words are the values associated with the keys. When you look up a word, you get its corresponding definition. This is basically how the dictionaries work in C# as well. You can use various data types as keys and values, depending on your specific requirements. So let's just start by creating a dictionary. Firstly, to create the dictionary, we need the dictionary keyword. And then inside this angle brackets here, we need to specify the data type of our key and of our value for the key value pairs that the dictionary will contain. So here I'm just making a dictionary of like an English language dictionary. So I'm gonna need to have a string for the key, which will be the word, and also a string for the value, which will basically be the definition of the word. So I'm gonna need to write two strings here. Then I'm just giving a name to the dictionary, like English dictionary. Then I'm just going to write the equal sign here, new dictionary. Then again, I'm going to need to specify the data type of the key and of the value. Then at the end, just a parenthesis here and a semicolon. So this here is the syntax of how you can create a dictionary in C#. So to add key value pairs to our dictionary, we're going to do this by using the add method. So basically, I'm just going to need to have here the name of the dictionary, dot add, and this method here accepts two arguments, one for the key and one for the value, which are both strings in our case. The first one, let me just say we want to see the definition of C# in our dictionary, and the definition will be a programming language. So let's just keep it simple. And this is the key, this is the value, and this is the first key value pair that the dictionary has now. Let me just add another one down below. So let's say we want a definition for a computer. Let's say a computer is an electronic device. Let's leave it like that. And there are different ways of how we can actually print the values of the key value pairs of our dictionary out in the console. But I'm just using a foreach loop here. So I'm looping through each key value pair. I'm going to need firstly a variable to loop through the dictionary. I name it dict. So this var keyword here basically is an anonymous data type, which basically means that the compiler will just figure out itself the data type that this variable takes. So we can use this for the dictionary, and we'll loop through our English dictionary here. And I'm just using the console.writeLine method. And actually, if I would want to print out to the console only the keys or only the values of our dictionary, I could just write here dict.key. Let me just run the program. And we'll see here that we have only the keys of our key value pairs, so the C# and computer. And the same way would work also if we wanted to print out only the values. As we can see here, a programming language and an electronic device. But there's a way for us to print out more than one value with this console.writeLine method in one line, and let me just show it to you. So firstly, I'm going to need a string. Here, double quotation marks. Inside here, I'm going to need two sets of curly braces. In the first set, I'm going to write the index of 0, and in the second one, the index of 1. And I'm just going to explain to you in a bit what this does. Afterwards, I'm just going to need to write here dict.key, comma, dict.value. So what these curly braces with the index of 0 represent, they represent the value of the first argument after the comma here. So the value of a dictionary.key will be put here, will be represented by these curly braces here, and the second set of curly braces will represent the second argument after the comma here, which is the value of the key value pairs. So if I run the program here, we should see C#, a programming language, and then computer, an electronic device. There's also another way for us to access elements, key value pairs of our dictionary, and let me just show it to you. So I'm using the console.writeLine method, and to access, for example, the value of our dictionary, a specific value, I'm just going to need to write the name of the dictionary here, and then inside square brackets, I'm going to need to write the name of the key, which let's say C#. And here, this is another way how we can access values of our dictionary. Let me just comment this out for a second. Run the program. We should see here the value of with the key C#. And I'm just going to comment this out here. We're going to use the foreach loop for the next examples. So if I just write the name of the dictionary and then that, we see here a whole list of methods that we can use to work with dictionaries. I'm just going to show you a couple of those. So the remove method, for example, takes one argument, which is the key of a key value pair of our dictionary, and then it removes that key value pair. Let's say we want to remove this computer, the key value pair where the key is computer, and if I run the program here, we should see that we only have this one key value pair now. The second value pair that we wrote here is now removed. Let me just comment this out as well. And there's also another method I want to show you, which is contains. So by just writing the name of the dictionary, then we have here two methods, contains key and contains value. And this method basically just returns true or false. And with this, we can just check if our dictionary contains a specific key with this method or a specific value with this method. Just use the second one. So let's say if our dictionary contains this value, this should return true. But for us to see it in the console, I'm gonna need to write the console.writeLine method. So let me just run the program again. And we see here true, since this value is in this key value pair here. Until now, in this C# series, we have stored data in variables or in a data structure like lists or arrays. And as soon as our program closes, this data is lost. A way to solve this problem is by storing our data in a file so that all of our information will be saved even after we close the program. In this video, we'll see how we can work with files, how we can write and read data from them, so just keep on watching. So here I have just opened up a console application project in Visual Studio. Here I have a program class and then a normal standard main method. What I'm going to do firstly, before we create the file and store text into it, I'm just gonna take input from the user. So firstly, I'm just gonna print a message in the console to, let's give a message to the user. Let's say enter a name. And then just underneath, I'm gonna use the console.readLine method to take the user's input. And I'm actually gonna store this input in a variable, in a string variable. I'm just naming it input here. And what I'm gonna do then, after we write a text in our console, after we write a name, and we're just gonna use the file class that write all text method. So this is the method that we're going to use. What this method does is that it creates a file and inputs a string that we specify into it, and then it closes the file. If the file already exists, this method just overrides the content of that file with the string that we specify here. So this method takes two arguments. The first argument is the name of the file. Let's say new file. If this file does not exist, this method will create it, and I'm going to make it new file.txt, so a text file. The second argument will take a string. So here I'm going to give the input that we created above. So if I run the program here, firstly we should see a prompt to enter a name. Here we see the console, enter name. I'm just going to use some name here like Matthew, click on enter, and that's it for now. So we should actually try to find this file, if it was created or not. This file will actually be created in the directory where this project that we're working on is saved. So to find it faster, I'm just gonna input the name of the file in this search bar here, .txt. Here we see this file and the location of the file, where it's in the same directory where our console application project is saved. So I'll just click on it to open it up. And we should actually see the new file here and the name Matthew printed into it. So if we would actually just run the program again, so that we'll see how this method works, let me just do it here. If I enter another name like John in this file, if I open up the file again, so it was this new file document, we see John. So the first name that we wrote was overwritten, and that's how actually this method works. Each time we run the application, each time this method works, it overrides the file with the content that it already has. But how we could process in this case if we would want to just add a name after another name? Actually, in those cases, we are going to need to use another method, which is the method append all text. So append all text. So this method, what it basically does, we could have used this method since the beginning. If the file does not exist, it creates the file. And if it does, it just appends the input that we give to this file one after another, so that the names that we input, the text that we input into the file are not printed just one attached to the other one. We can just add a new line after each input. So for this reason, I'm just going to use the string interpolation here. So I'm just going to use the double quotation marks in the beginning. In the end, we need this $sign here. And after we take the input, I'm just going to need to write slash here and for a new line. Let's just run the program and see how this works. So let me just add another name, like, I don't know, something with Z. So Z. I'll run the program again, and I'm going to input another name like Aaron. Run the program here, and then just find the file just again. Here, what we see here, we see that Z was inputted after John, but without a space, and then Aaron was saved in a new line. This happened actually because firstly, when we used the writeAllText method, when we made the input here, we didn't enter a new line at the end. That's why Z is just attached to John. We could actually could have used this since the beginning, but for me, to make it faster, I'm just gonna input the new line manually here and save the file. Or we could have used this in the beginning when we created the file. So as we saw here, we saw two methods to write text into a file. Now we're going to see another method of the file class to actually read the content of the file. This method is called readAllText, and it takes one argument. It takes the name of the file, which is new file, so it reads the content of the file and then closes the file. That's what this method does. So for us to actually see the output of this file, I'm going to need to use the console.writeLine method. And for us to not add any other name to our program, I'm just going to comment these lines out. So if I run the program here, let me just see it, we see only all of the elements, all of the text that our file has. We see John, Seth, and Aaron. So actually a practice when we read specific data from a file, it is a good practice, it's a common practice that if we want, for example, to modify the content of our file or to make sure that the file is structured in a specific way, we actually get the data from the file, we store them in a data structure, let's say a list, we make the modification or the format that we want the data to be presented, and that's the example I'm going to make right now. So actually I'm just going to create a simple list here, a list of strings. So I'm naming it just list since it was already pre-made here. New list, a list of strings, and this is the way we declare a list. So I'm just going to comment this line out for now. So what I'm going to do here, I'm going to need the foreach loop to loop every line of our file. So for each, let's say, line in file.read all lines. So I'm going to use this method right now, which just reads through all of the lines of our text file. Remove this. So basically what this does is that it reads through every line of our file. I'm just going to need to specify, it takes an argument, I'm going to specify the file name, which was new file.txt, and each line of our file I'm just going to add to our list that we created. So I'm writing here list.add and then a line. So in this point here we have added all of the lines in this list that we created here, and down below we can actually do what we want to the list. Let's say we want to list the items, we want to sort the items that the list has. So we're using this sort method here. It just sorts the items that the list has alphabetically. So they should be listed out in an alphabetical order. So after doing this, I can also just use a foreach loop again to just print each item of the list in the console. So for each item in list, I'm just gonna print each item out of the console. Let me run the program. We should see Aaron in the first place, then John, and then Seth. Exceptions in C#, like in any other programming language, refer to problems or errors in your code. Exceptions are a mechanism used to handle runtime errors or exceptional conditions that may occur during the execution of the program. When an error occurs, an exception is thrown, and if the exception is not handled, the program terminates and an error message is displayed. And in this video, we're going to see what we can use in C# to handle these exceptions. While coding different projects, it is very common for us to make different kind of mistakes. One of the most common mistakes or errors that we do while coding are these syntax errors. In this simple line of code here, if I, for example, forget to close the line with a semicolon and I try to run the program would not allow me to, because as you can see here, we see the error which basically says that a semicolon is expected there. But errors may happen also when the program is running. When a user is using our program, an error occurs, and then the user may just get this long text of errors, of cryptic error, and the program would stop. And this is actually a case that we need to handle, and we need to prevent this from happening. This is what we'll basically see in this video. I'm just gonna leave this line of code here as it is, and underneath I'm just gonna make our program so that it takes input or a number from the user, and I'm actually going to store it in an integer variable. I'm naming it number, and I'm going to use the console.readLine method here. But as we have seen also before, this method just takes a string. For us to convert what we take from this method into an integer, I'm just going to use the convert to int32 method. Convert. And underneath I'm just gonna also print this variable to the console. Let me just run the program firstly. And we see the prompt here, enter number. If I enter a correct number, let's say 45, 45 will be printed out and the program ends. But if I try again to enter, let's say, a string, which is basically just a sequence of text, we will see this long cryptic message here. We can understand it here that the input string is not in the correct format, but this shouldn't happen to a user. This kind of error and this kind of message shouldn't be in this way. And there is a way for us to actually manage this in C#. In C#, we use the try and catch blocks. So basically for each part of code, each piece of code where we think that an error may occur, we actually put this code inside a try block. Let me just input all of this code here. And after the try block, we can write multiple catch blocks. So what the catch blocks do is they actually detect exceptions and let us do something specific after detecting this exception. There are different kinds of exceptions that we can catch with these catch blocks, and we can actually specify the exceptions that we are looking for. Let's say I'm looking for a format exception. We can see if that's why the error occurred. I'm just giving a name to the variable like e. And each time this kind of error happens, we want to print something out of the console. We could just print a custom message here, but I can also just print out, just use this e variable here and use this message method which just basically prints out the message of the error. Not all of these lines, of all of these cryptic lines, but basically the main message that the error has. And let me just try and run the code again. So in this case, this try block here, the program, when it goes to the try block, it checks for an exception, and then it goes to this catch block. So let me just write a piece of text again. We will see this message printed out to the console, which is the input string is not in the correct format. And as I said, after the program reads the try block here, and it tries to get an integer from the user, an error occurs, and that's why the program goes to this catch block. It sees that this is a format exception, and for this reason, this message will be printed out. But even though the text is more understandable and it's shorter, still that's not a good user interface, or it's not a good implementation of the program, because the user may just make a mistake, just a typing mistake, and we would want for the user to try and input again the right data. So what we can do in this case is actually just put this whole try and catch block inside the while loop, so that the user will try and input the correct the data until it is the data that is required from the program. So I'm just making the condition here true. So the while loop will run as long as we break out of the loop, as long as we decide to break out of the loop. So I'm just cutting this code, inputting it inside this while loop, and we want for the program to actually break out of the loop if this input here is correct. So after the program reads this line here, then it takes the input from the user. If the input is not an integer, then the program goes to this catch block, and then the while loop runs again. The prompt will ask the user again to input a number, and if the number inputted by the user is an integer, actually, we want to break out of the loop in this part here, so that the user won't be asked again to input a number. Let us just try the program here. Enter a number. If I enter a correct number, we just see the number is printed out here and the program breaks out of the loop. But if I enter a string again, we'll see the error message here that's printed out. The input is not in the correct format, and then the user is asked again to input a number. If I input a text again, we will be still asked to input a number. And if I write a number, then the number is printed out and the program basically ends. We can write as many catch blocks here as we want. Just the logic behind it is that the program just reads the catch blocks from top to bottom. And if one catch block has the actual exception, then the program just executes the one catch block and the other ones won't be executed or will be ignored, even if they are valid as well. So for this reason, the logic behind this is that we want to write the most specific cases or the most specific exceptions on top. And then on the bottom, let's say we want to write like a general exception, which is done by this exception keyword here. So this catch block here is just a general exception, which basically gives us a general error message. Sometimes the error message is correct, but sometimes this block does not print out the specific error that occurs in the case. For this reason, this is like mostly recommended to be inputted at the end. And I can actually just, let's say we want to have another exception, like another kind is divide by zero exception, which just catches exceptions where division is done by zero. In this case, this will basically not happen actually, but let me just do something here. Let us just print out to the console, let's say 4 divided by the number. And let me run the program. I will enter number. If I enter 4, the result is 1. But if I enter 0, we see this error message attempted to divide by 0. So the program firstly checks the first catch block. It's not a format exception. And then it checks the second block of catch. The exception actually happened because it was a division by 0, so the message is printed out to the console and the program just runs the loop from the beginning. In the case when, let's say, the exception was not a format exception or division by 0, then the program would run the last block of code. So in our case here, if I enter the correct number, we should see that 4 divided by 47, it's 0. The last thing for this video is that you can also write another block of code in this try and catch blocks, the finally block. So the finally block is the block that is executed in all cases. So even if the program catches an exception, this block of code here will be executed, and even in the cases when the program won't catch an exception. So normally this block of code is used, for example, in those cases when we want to reset a variable, or when some files are opened, we want to close a file. But in our case, I'm just printing out like a custom message, let's say block of code ended. If I run the program here, let me input a correct number. We see firstly the result here, and then the block of code ended. If I run the program again, I'm inputting a text. We see the error message, then we see again this block of code, the message in the finally block here getting printed out. So the block of code ended, and we are asked to input a number again. If you want to learn ASP.NET Core MVC from the ground up, this course will take you there. We'll start by breaking down the entire MVC app structure, exploring every file, covering the main concepts you need to know, and then dive into working with databases using Entity Framework Core, from CRUD operations to complex database relationships. We will be using the latest .NET version, .NET 9, and it's going to be super simple. I'm going to explain to you what the MVC architecture is in programming, and I'm going to walk you through everything you need to know. MVC stands for Model View Controller, and it is an architectural pattern that divides an application into three primary components: models, views, and controllers. This separation helps achieve a clear division of concerns in our applications. Separating concerns or responsibilities in MVC makes the application easier to develop, debug, and test because each part, either the model, the view, or the controller, has a specific job. When responsibilities are mixed, like combining user interface and business logic, changes to one can affect the other, making updates and testing harder and more error-prone. For example, user interface logic changes often, so if it's combined with business logic, you'd need to modify and retest both every time the interface changes. Now let's see each of these components in more detail. The model in MVC represents the information or the data the application operates on and handles the logic for processing this data. For example, if you have an application for managing books in a library, the model would represent the data about the books and the rules for adding, updating, or removing books from the collection. A view in MVC is the part of the application that displays the data to the user. A controller then manages user input and interaction, determining which model types to work with and which view to render, effectively controlling the application's response to requests. I'm going to show you how to download and install .NET 9 and the latest version of Visual Studio, which is our IDE, in order to be able to work in .NET 9. So let's get into it. So I'm just going to click on Google, download .NET 9, and we'll see the first thing we have here in the Microsoft's website. We should be redirected to the page that allows us to install the .NET 9 SDK. In the time of recording this tutorial, we have the 5th preview of .NET 9. Probably when you will see this, it will be fully out, the final .NET 9 version, but this is what we'll use, and there shouldn't be many changes with the final version. So here we have .NET 9 preview 5. Depending on your operating system, here just choose the correct one for you. I am using Windows and my processor is a 64 processor. I'll select this option right here and we'll wait for .NET 9 SDK to be installed. So it is already installed. Let me click on it. Click on install here. Okay, the installation was successful. Let me close this window here. And now if we just go back to the page we previously were, we can actually check we can go here to .NET Preview 5 to release notes to see what version of Visual Studio .NET 9 actually requires. If we scroll a bit below, we will see that .NET 9 is compatible with Visual Studio 17.11 latest preview. And if I click on it, can basically download the latest version here in this part by just going to Community 22 to download the free version. And the downloads start right here, but I actually have the Visual Studio installed and I could have just updated it on my application, but let's see how it works right here. If I click on it, I should receive the option to actually just upgrade. Continue. Now the Visual Studio installer is opened and it gives us the option to update to the latest version. I'm just going to click on update and the download starts. We'll give it a bit of time. Now, after a while, the Visual Studio's latest version is already installed, as we can see here. So we have the latest version of .NET, the latest version of Visual Studio, and we are ready to go. Now, one last thing you want to do if you are using a preview version like myself is actually going to need to go to the settings to Visual Studio to allow these previews. So let me open up Visual Studio. Click on Continue without code, so I don't need to open a specific project. Go to Tools. Go to Manage Preview Features. And a bit below, we should see an option here. We should click on this option here, Use Previews of the .NET SDK. This enables the ability, as we can see here, to consume preview SDKs by default. If I click on it, click OK. If we restart the Visual Studio, then we should be able to work with the preview version of .NET 9. You need to know the contents of each file in your project when building anything in programming. For this reason, I'm going to explain to you concisely the role of all files you have when you create an MVC web application project in ASP.NET Core. To create our first application, we can just open Visual Studio and click on Create a new project. Next, find an MVC template for a web application and make sure that C# is the language for this template, not F#, for example. In the page that loads, give a name to your app, like My App. You can change the location where you want your project to be stored if you want as well. Click on Next, and here I will select the .NET version to be .NET 9, this preview version, but the final release of .NET 9 may be available by the time you watch this tutorial. Let's leave all the other settings as they are for now and just click on Create. Here we have our application. When you create a new ASP.NET Core MVC project, several key files and folders are automatically generated. Let's go through them one by one. First, we have the program.cs file. This is the entry point for the application. This first line initializes a new instance of the Web Application Builder class, which sets up the configuration, services, and the web server. Next, we add services to the dependency injection container. Here we are adding MVC services to the container with support for both controllers and views. This allows our application to handle incoming HTTP requests and render HTML views. Then we build the application. This line compiles the app, creating a web application instance, which you can then configure and run. Now we configure the HTTP request pipeline, which determines how requests are processed by the app. If the app is not in the development environment, we set up an exception handler to redirect users to the home/error page when an unhandled exception occurs. Additionally, we enable HTTP strict transport security to enforce secure HTTPS connections. We continue configuring the pipeline with this app.use HTTPS redirection, which ensures that HTTP requests are redirected to HTTPS, and app.useRouting enables routing, which allows the app to match incoming requests to the appropriate endpoint. Next, we have the app.useAuthorization, which is responsible for authorizing users to access secured resources. We map then static assets. This line enables serving static files such as images, CSS, and JavaScript from the www.root folder. Then we configure the default route for the MVC application here. This sets up the default route pattern, which maps to the home controller and its index action method by default. The ID parameter is optional. So this is the default route that will be redirected to when we start our application. Every URL is actually assumed to have this pattern. The first part is the controller, then a method of that controller, which is actually called an action in ASP.NET Core, and the ID that is optional. Let's say a request is made to a URL called /items/overview. Our application will try to call an action called overview inside an items controller. And now let's go to the last line. Finally, we run the application. This line starts the web application and begins listening for HTTP requests. Now, let us now see what the other folders do as well. Just as a reminder, if you want to get the fundamentals right while learning C#, you should check out my ebook, which is on sale now. It will help you with whatever you're building in .NET and save you hours of research by providing all the C# insights you need in one place. This book will be a valuable resource for everything C# related, and you can find the link in the description if you want to check it out. Now back to the video. The controllers folder contains the controller classes. These handle incoming HTTP requests, process user input, and interact with the model to return the appropriate view. For example, we have the home controller here that is already created. The models folder then contains classes that represent the data of the application. Here we have a sample model, errorViewModel.cs, which is used for error handling. The views folder contains the eraser view files, or the .cshtml files, used to render HTML to the client. In this folder, you'll also find the view imports.cshtml, which contains directives that are imported into every view, such as tag helpers, and the underline view start.cshtml, which specifies common view configurations like the layout. Within the views folder, there's also a shared subfolder, which contains shared views like the layout, which is the layout page that is used as a default design for all pages, and this underline validation scripts partial.cshtml file, which contains client-side validation scripts. There's also a home folder, which contains views related to the home controller, such as the index view page and the privacy view page. The www.root folder is the root for the application's static files like CSS, JavaScript, images, and other assets. Inside, you'll find subfolders like CSS for style sheets and JavaScript for JavaScript files. For example, site.css and site.js are default files included for your custom styles and scripts. Next, we have the configuration files. The app-settings.json file is the main configuration file for the application. It contains settings like connection strings and app-specific configurations, which we'll see later on. Let's take a look at the properties folder as well, where we have the launch-settings.json file that contains settings related to how the application is launched during development. They can be modified to suit the specific requirements of the project or different development environments. And that's a quick overview of the main files and folders in an ASP.NET Core MVC web application project. I'm going to show you the basics of ASP.NET Core MVC using .NET 9. We will see how to work with the models, the controllers, and the views, and how they interact with each other, all in this short video. If you're new to MVC, this is the perfect starting point. I'm just going to go to the models folder and create a new model, or basically a new class for the models. I'll name it, let's say, item.cs. We'll see that a simple class will be created. Now, this class represents the data of our application. If we were to store this, which we'll do later on, in a database, this class that's stored in the models folder will represent a table in our database. And each property that this class will take will represent the different columns that the table will contain. So we can give to this class different properties. Let's say, let me just give it an ID property firstly, and I'll explain everything. So basically, we're setting an access modifier to public for this property so that it can be accessed outside the class. The ID, we name the property here, and it will be an integer. This is the type of data. And here we have a getter and a setter that allows this property to be accessed outside of our class. So this is an auto-implemented property. This is just some C# theory here. We can specify here different properties for our model, and we gave each item an ID. We can give also each item a name. I'll set it to be public string. The name will have the data type of string. I'll name it name, and the getter and setter as well. Now let's say we want to access this item in a specific URL pattern. Let's say that it would be /items/ let's say overview. So we'll create this application so that when a user makes a request to this URL, it will be redirected to a page that gives him the item. For this reason, what we're going to need is we're going to need a controller named items, and also an action in that controller named overview. Let me just go to the controllers folder and add a new controller. I select an empty template here, click on add. I'll name the controller to be items controller. And we'll see a simple class here, an items controller, the items controller class, which inherits from a base controller class. Basically, every controller will inherit this base controller class because it inherits multiple methods, but you do not need to worry about this for now. We can see, as we talked before, each method in a controller is called action in ASP.NET Core MVC. And here we see this index method, or this index action here. This is a public method. It returns an IActionResult and it's named index. I'm gonna clarify to you in the next section what IActionResult means in more detail, but basically this just allows our method to return different types of things. In this case, we are returning a view, which is actually included in this IActionResult return type. But as I said, we'll talk about the action parameters and action result types in the next section. For now, what we'll do is that I'm going to actually change the name of this action to be overview, since we wanted the user to be redirected to this specific route. And I'm going to take an instance. I'm going to create an instance of the model that we just created here inside this action, taking a variable, naming it item equals to new item. And I'm going to need to import the model on top of the controller so that the controller knows the model basically that we created before. So I'm going to need to use this using directive, the name of the application, .models here. And as you can see, this item keyword is now in green because the page recognizes what it means. And let me just create one item here. It's not necessary for me to give an ID to the model because the program will give it itself. So I'm just going to specify for the item the name property. And let's give a name to a random item. Let's say keyboard. And that's it. So I have created an item here, and I'm going to pass it actually to the view, so that we can be able to render this item that I created here inside the view that we'll basically need to create. What this action here does is that it creates the item, it renders the view, but we're going to need to create the view because we don't have a view named overview yet. We can just go to the views folder. We're going to need to actually create a folder to store all of the views inside the items controller. For this reason, I'm going to name it items. And inside this items folder, we can store views for each action in this controller. And for our case, I'm creating an empty view, and I'm naming it according to the name of the action, which was overview. And here we have our overview CS HTML page. Here we can write the plain HTML code that will be rendered to the user, but we can also embed here C# code, which we'll see in a bit, what we want to store in this page. I'm actually writing a HTML paragraph here, and I'm going to display to the user, this is the name of the item. And for me to actually access this item model that we created inside our controller here, that we put as a parameter in the view, I'm going to need to import the specific model on top of our view page. I'll do it by just writing this @ model and then the exact address of the model that we created, which is the name of the application, .models, the name of the model, item. And now I can access the item that we gave into the view by just writing this @. The @ will use a lot. This is how we basically write C# code inside our view pages. And for me to access the model, I need this model keyword and @model. And here I can access the ID or the name of our model. I'm going to access the name here in this case. And now if we run the project, let's see what we have written now. Now, this is our home controller, the index page, the default route of our application. So this is what we'll see here. But if we go to /items/overview, we will be redirected to the items controller, to the overview action, which will actually render our overview view page. Let me just hit enter, and we should see here, this is the name of the item, and then the name of the item, which we specified by using this C# code in our view page. So this is just the basics. It may seem a bit complex right now, but you have worked with models, controllers, and views all in this short video. I'm going to explain to you what IActionResult is in ASP.NET Core, why we use it, and I'm going to walk you through everything you need to know. In the previous section, we saw inside our controller that the actions return this IActionResult. But what is the IActionResult? IActionResult is an interface that basically defines a contract for all the different kinds of results that an action can return. Inside of an action, we can return to the user different results. We can return a page, we can redirect the user somewhere, we can return a JSON, just a simple message, and so on. All of these different action results derive from the IActionResult interface. In some cases, we may have a condition inside our action which would return different information to the user depending on specific requirements. And in this case, for us to include each of these different return types in the return type of the action, we specify here IActionResult instead of just specifying, let's say, view result or content result, so that it includes everything that the action can return. Let me just remove this and show you what we could use if we didn't use the IActionResult. If we would want to just return a view, let's say we can just return here a view result and then return the view here. Actually, the view that we are returning here is just a helper method that is inherited from the controller class, and it's just a shortage of this view result. The long way of writing it would be return new view result. But as I said, this is a helper method that allows us to write it in a more flexible and short way, and this is the way you will mostly see it in the code or from the documentation. So we could return different kinds. We could also return other kinds of information inside a action. We could return content result. Here I can just write return content. Content is as well a helper method. Here I can just write a message to the user like hello there. We can return just JSON result, a redirection result, and so on. But every of these different result types inherits from the IActionResult. And as I said, that's why we basically just write on top of as a return type of every action IActionResult, so everything is included in it. I'm going to explain to you what action parameters are in ASP.NET Core and the different kinds of them. I'm going to walk you through some examples as well so that you'll learn how they work. So let's get started. Action parameters are a way for our actions to receive input data. This input data can come from different sources, such as URL segments, query strings, form submissions, or even a combination of some of these. Let's just start to see how the URL segment parameters work. In our items controller, I'm just going to create a new action. So public IActionResult, I'm actually going to name it edit. And here in this action, I'm going to receive an int ID parameter from the URL. And in this case, the parameter is passed to the action directly from the URL depending on the route configurations of our application. If you remember in program.cs, the default route pattern here is specified and it actually allows us to receive an ID parameter. Okay, so let's go back to the controller. And I'm just going to return on the screen some content. I'm going to write here return content, and I'm just going to return basically a message on the screen. So I will return the ID. Then I'm going to pass here the value that we get of the parameter that we get from the URL. Let me just run our project. And if I go to this specific route to items, the name of the controller, / edit / let's say 231, whatever number you want, we'll see that the parameter is passed to the action from the URL directly, and then we have displayed this parameter on the screen. So we can see here that the ID is equal to 2. Now let's just see how the query string parameters work. So query string parameters are this part in the URL that comes after the question mark, and they are usually used to filter or to sort. This method is usually used to filter or to sort data actually. Let's just see here how it works. So after the edit part, we'll input here question mark and give the ID the value of, let's say, 4. Click on enter and we can see on the screen that the ID has the value of 4. So the parameter is passed from the query string to our action, and we see here the value of the ID on the screen. Now, another way would also be, as I told you before, to take data from form submissions, but do not have the necessary knowledge yet. So I'm just not going to take an example for it. And one last thing I wanted to mention is that if we would actually change the name of the parameter we take from our action here, let's say change it to item ID, we would be able to still get the data from the query string, but we would not be able to take this from the URL segment, just because in the program.cs file here in the pattern of our route, we have specified that we can take from the URL can take an ID parameter and not an items ID parameter, so to say. So if I just go back here, run the project, let's say if I go to the route here, items / edit, and I write this query string, items item ID equals to 5, we should still see the value of the ID printed in the screen. But if I would do it using the URL segment, like edit /7, we would see that the value of the ID would default to 0, just because we are not taking the value from the URL in this case. Razor is a markup syntax used in ASP.NET Core to embed C# code into HTML. It's designed to be clean and concise, making your code easier to read and maintain. You'll commonly see Razor syntax in views, which are responsible for rendering the UI. Razor syntax is denoted by the @ symbol. Now let's look at some common uses. First, let's start with basic variable embedding. Suppose we have a variable that we want to display in our view. In this example, we declare a variable message inside this code block that we can write inside our view pages and use the @message syntax to embed its value inside a paragraph tag. Razor also supports embedding more complex expressions and C# code blocks. For instance, let's loop through a list of items and display each one of them. Here we use the @foreach loop to iterate over a list of items and output each item within a list tag. Notice how we seamlessly switch between C# and HTML. Razor syntax also includes conditional statements, which are useful for rendering different content based on certain conditions. Let's see an example with an if-else statement. Depending on the value of the isLoggedIn variable, Razor will render either welcome back or please log in. This makes our views dynamic and responsive to the application's state. Now let's talk about the Razor directives. Directives are special instructions for the Razor engine, and they're prefixed with the @symbol. Some common directives include @page, @modal, and @using. For example, the @modal directive specifies the type of modal data the view expects. This is crucial for strongly typed views. In this example, the @modal directive is used to indicate that this view expects a myViewModal object. We can then access the modal's properties using @modal. Lastly, Razor has a feature called tag helpers, which allows us to dynamically add behaviors and attributes to HTML elements. Tag helpers make our Razor views cleaner and more maintainable. Here's a simple example using the ASP4 tag helper. The ASP4 tag helper binds the input field to the name property of the modal. This ensures that the correct value is posted back to the server when the form is submitted. So what is Entity Framework Core? Entity Framework Core is a toolset for .NET developers that simplifies database access by allowing us to work with databases using .NET objects. It eliminates the need to write complex SQL queries by providing a way to query and manipulate data using C# code. Entity Framework Core supports various database operations like creating, reading, updating, and deleting data, making it easier to manage database interactions in an object-oriented manner. There are two main approaches to using Entity Framework Core: the code-first approach and the database-first approach. In this video, we will learn how the code-first approach works. The code-first approach in Entity Framework Core allows us to define the database schema using C# classes and then generate the database from these classes. The database-first approach works the other way around. The code-first approach is ideal when starting a new project without an existing database, as it provides full control over the data model through code. Okay, so we're going to start with the code-first approach, and we're just inside our MVC web app template here. In Visual Studio, the first thing we're going to need to do is go to the dependencies here, click with the right of the mouse, and select Manage NuGet Packages. We're going to need to install the needed NuGet packages in order to implement Entity Framework Core inside our project. So the first package we need here is Entity Framework Core. The first one you see here, click on Install. Click on I accept. Next, we need the Microsoft Entity Framework Core tools. Click on Install as well. And then the Microsoft.Entity Framework Core.SQL Server, since we are connecting our project with a SQL Server database with SQL Server Management Studio, actually. Click on it and install. So all of these packages that we're installing right now have necessary tools and commands needed for us to basically map our C# classes and models and generate a database and connect it basically with the SQL Server database. Okay, now that we have all of our 3 packages installed, let's just check the models that we have in this project. So here I have only like a simple item model with an ID property and a name property. And we will store this model inside our database. What we're going to need other than our model, we're going to need a context class, which as a practice is stored inside the data folder. And I'm just going to explain to you what the context class is needed for, but let's just create the data folder firstly. Just add a folder called data. And inside the data folder, we're going to add a class. I'll name it my app context or something with context in it. Click on add. Now here we have our context class. We are going to need that our class inherits from the entity framework course DB context class. And let me see what we need to inherit here. We need actually to inherit entity framework core on top of the page, I would suggest. Using entity framework core on top of the page, and this class basically contains many properties and methods in order for the context to do its work. So the context is this class, like the main bridge that connects our project with the database. Here we store every instance of the models we have in our project, and with the context, with the method that the context provides, it's possible to basically query data from the database, filter them, get the data, or modify them. What we're gonna need after inheriting the DB context class is we need a constructor inside our context class, and this will just contain a few generic parameters to enable the needed configurations for our context. So these are the parameters that our constructor needs to have. And what we also need to write here is, as I told you, we need inside the context, we store an instance for each model that we have in our project. In this case, we have this item model, and we need a dbset instance, which is this entity framework class, and this will be for our item model. We give it a name like items, and we give it this getter and setter. So this is written just like a property and enables us to access this model from the database, and basically what we have in our project to start in the database. We need to import the models folder on top of the page, my app.models, and this is it for the context. The next step we need to take is to create a database instance in our SQL Server Management Studio that we're going to use as the database for our project. We can just go to the View menu here and click on Server Explorer. Here we have all of the basically a lot of database instances I had created before. We just need to go here to Data Connections, click with the right of the mouse, and click on Create New SQL Server Database. Here we need to write the server name, and basically if you open up the Microsoft SQL Server Management Studio, you'll see the server name on top of the page. If we can just click the name of it here, connect the SQL Server Management Studio to our server, and go back to the project. We put the name here. We'll use the Windows authentication to log on to the server. The encryption will set to false. click on Trust Certificate here. We're just selecting here the authentication. This is a default one. We're selecting that we do not need to use a password to connect to our database. Basically here, just some options, just some configurations. Don't think too much about it. And give the database a name, like my app database. Click on OK, and after the database will be generated, we should see in this window right here the name of the connection string. The connection string is the address of the physical database. So basically this tells us where the database is located. We should copy this, and the connection string we need to input it in our app settings.json file so that we then can connect our project to this physical database. Here we need to write connection strings, and we need to give a name to the connection string. I usually name it like default connection string, it doesn't matter. Here we input what we took from we input the name of the connection string, just right here with the name of the server, the name of the database, as you can see here, and we put the encryption to false, and some other configurations. The last step now to connect our project to the database would just be to go to program.cs and add a service in the services containers. Basically, this will connect our database with our project and with our context. So I'll just add the service here, builder.services that add context. The name of our context was my app context. Here inside we'll just input a few options. Let me input this in a new line. Options does use SQL Server. And inside here we need to access our connection string to get the location of our database. Builder.configuration.get connection string, and we need to input here the name of our connection string. Connection string. Just close the parenthesis here. So basically we are writing a service to connect our context basically with our database here. Just let me remove this dot here. We need to import entity framework on top. We need to add the migrations to our database. A migration is basically just a class that will be created that is the code, the representation of how our database will look like, with all of our configurations for our models and the context that we have already written here. So to do that, we're just going to need to go to Tools, Package Manager Console here, and just write a command, add -migration, and just give a name to the migration. Hit on enter. So build succeeded, and we should see this migration class here on the screen. A migrations folder will be basically created. The migrations track every change we do to the database schema, and each time we change the models or the context, we need to add a new migration to the database. You can see here that the table will be created on our database with a columns, an ID column, with its specifications and a name column here. The primary key is by default the ID property, as we can see here. And the last thing we need to do is to basically write the comment here, update database, and this migration will be added to our database. Right now, a table for our items should be generated already in our database. If you go to SQL Server Management Studio, to databases, let me find the right database of our project, which were my app database. You can click on tables. We have a table for the migrations here, Entity Framework Core Migrations History, which basically tracks all the changes to the database schema that we make. And right below, we see the items table. If we click on Edit Top 200 rows, we should see basically an empty table, but the table with an ID and a name. We can click on Design here to see our columns. So this is how Entity Framework Core's code-first approach works. In this video, we will learn how the database-first approach works. The database-first approach in Entity Framework Core involves generating C# classes and a DB context from an existing database schema. This method is suitable when working with a legacy database or when the database design is managed outside of the application development process, allowing us to integrate the existing database into the application seamlessly. I'm in SQL Server Management Studio here, and I have a database, and basically I have 3 tables here, 3 pre-populated tables, a dishes table here, an ingredients table, and a dish ingredients table. And I'm going to use this database to create the models and the context in a new project. So I have just created a new MVC web app project, and I have already installed Microsoft Entity Framework Core, Framework Core.SQL Server, and Microsoft.Entity Framework Core.Tools. So you need these 3 packages to be able to work with Entity Framework Core. And now what we will do is just go to Package Manager console here and write this command, scaffold -db context. Then here we need to input the connection string of the database that we will import. So I have already copied it. After this line, we need to write here Microsoft.Entity Framework Core.SQL Server. Then we need to write -context directory data. So here we'll specify in which directory our context will be stored, which will be stored in a folder named data. And then output directory. Here we specify the directory of where the models will be stored. So they will be stored in the models folder. And I will specify here the data annotation flag. What data annotations are basically these attributes that each property in our models take to basically validate them, to specify the relationship with each other or how they will be stored in the database. And if we specify this flag here, when the models will be created, the data annotations will be included in them. So now if you just hit enter, we'll wait for the build to succeed. And the build succeeded. If we open up our models folder here, we'll see that in our models folder, we have the dish model. These are the data annotations that were included in our models. We have the ingredient model right here. And in our data folder, we have our data context. The dish ingredient helper model was not created as a separate model in our models folder, but the relationship between dish ingredient, dish, and ingredient models was specified in the DB context in the onModel creating method. It's a bit different from how we typically specify it, but it should achieve the same result. CRUD stands for Create, Read, Update and Delete, and these are the basic operations included in every application. We will perform these operations on our data in this project and show the changes in the front end. We have already created a simple model and stored it in the database using the Entity Framework course Code First approach. This is the MVC project. We have only one model. We created a context and we stored these changes to the database. Now, one more thing I'm going to do before we start is that I'm going to add another property to our model just because it's a little too short. But we'll still keep it short so that you understand everything better, so that it is the most simple thing ever. So I'm just going to add another property, a double property named price for our item. We have already created migration and stored it in the database for our project. Now that we made a change to the model, we're going to need to add the migrations one more time to our database. For this reason, we just need to go to Package Manager console and click Add Migration and put a name here for the migration. Let's say second migration. Hit Enter, and basically this migration class that represents our database schema should be created, that should be displayed in the screen, and of course added in our migrations folder. So we'll just wait for the build to succeed. And this is the migration that we already created. So a new column was added to our database, to our table in the database for the price. And now just need to click on to write the command update database to perform these changes to our database as well. Build succeeded. So now we just need to go to our items controller, and this is where all of the actions that will perform the needed operations will be stored. I'm just going to delete these two actions we had created previously. And first of all, what we're going to need is, for us to access the database, we're going to need to import the context in our controller. Firstly, I'm just going to need a private read-only variable to basically store the context, and we'll use this variable to do all sorts of methods that we can use from our context. But right now, just let's create this variable. I'll name it with the name of the context here. So this variable will hold our context. I'll just name it underline context, just as a practice. And inside the constructor for our controller, here we'll take basically the context by writing the context here and a variable to represent it. And then in the private variable that we declared above, we are just going to need to add the value of the context to our context variable that we'll use in the controller right here. Add a new line here. After storing the context in this variable, now we'll start with writing each of the actions. The first action, it's going to be a public IActionResult. I'll name it index for the main page, which will basically just display all of the items that we'll take from the database. And here we're going to return a view, but we need to return a view with the items that we'll take using the context from the database. For this reason, I'm just going to take a variable, call it item, and I'm going to access this from the database by using the underline context variable dot items to access the instance of the item created in our database, in our context that we have here. And then we need to write a method to list all of these items, just like this. But in such a case, when we query data from the database, it's recommended, and it's always what we do, is that we make the method, the action method, to be asynchronous. An asynchronous action method basically allows us to await some data from the database, which means that the method will stop until we take all of the necessary data that we need and then continues where we left off. For this reason, to write an asynchronous action method, we need the async keyword here on the method, and then this method needs to return a task of IActionResult. And we need as well to write the await keyword in front of the part where we query the data from the database. And in a case like this, we need to use as well the toList async method, which lists these items asynchronously. We need to import entity framework core in order that it recognizes the toList async method. Entity framework core. Now we do not get an error here, so basically what we did here, our asynchronous action method allows us to wait until this task is fully performed, and then it continues to return the view, and the view should contain all of the data that we take here from the database. Now, after writing the index action method, we need to create the view page. To create a view page, let's just go to the items folder, which is the name of the controller. And here I'm gonna create a new view page with the name of the action, index.cshtml. Let's remove this part here. Now, in this view page, we use Razor syntax to basically embed the C# code in our views as well. And on top of the page, because in this page, we are going to display a list of the item models, we need to use the @, directive in order to import a list of these models. To access them, I'm just going to need to write the name of the application, .models, the name of the model. We could also just import this directory on top of the page, but just to write everything in one single line. That's why I'm using it this way. And in this code block here, we usually specify the title of our page, the title of our tab. Basically, we do this with a view data, which is a dictionary in C#. This works with key value pairs, and we can set the value of the title by just writing view data title here as the key, and then we input the value in form of a string, let's say index here for the index view page. If you actually go to the layout page where we specify what will be displayed in the title of our page, you can see here that we can give a value to this view data, to this dictionary, with a key of title, and we automatically give it this text afterwards. We can remove it, we can leave it as it is, so that on top of the page we'll see, let's say, index-my-app, the name of the project. And this is how basically view data works. Now back to the index view page. Here we can give a header to our page, like an h3 header named index. And we usually use a table to represent a bunch of data. That's the example I'm using in this case. So like an HTML table element. With a class of table, and we'll separate it into sections. Table head for the head of our table. This is just some HTML syntax. And table body for the body of our table. In the table head, we can use this table row tags to write everything we want to be displayed in the first row, basically this table head. And we can use a table header here by writing th. And here we can input the name and the price of the table, the price of the item. If I just run the project, so that you see what we're doing at this moment. Just click with the right of the mouse here. In the view page you want to be displayed, and then click View in Browser. So here we have specified the table header, only the name and the price of the table, and then the data will come down below in the table body. So in the table body here we can use a foreach loop. This will be a C# code, and the Razor pages allow us to use C# conditionals in it by just writing the @ sign and then the foreach keyword. Here we'll take a variable and give it a name like item, but it doesn't matter the name of it, in model. So this keyword is important. So in a variable we just create a temporary variable here, and we are looping through the model that we are inputting here on top of the page. And down below, inside a single table row, we will display, by using the table data tags, the name of each item by writing the @item, which is the name of the variable we specify here, that name, and another table data for the item that price. And so the price is basically formatted as it should be. We can use this toString method, and inside parentheses the n2. This is just a method that basically displays the price, which is a double with only 2 places after the comma. In the last table, in the last row here, I'm using another table data tag to have 2 links to redirect us to the edit and to the delete page that we'll create later on. So we'll see a table with a list of items, and by having 2 buttons there, 2 links, we'll then be redirected to an edit page for that item, or to a delete page to delete that item. These action methods that I'll redirect you right now will create later on, but just that we have it there. So I'm going to use these anchor tags to redirect us to an edit link, and inside this anchor tag I'm going to use an tag helper, an ASP action tag helper, and I'm giving it a value of edit. Now, what are tag helpers? Tag helpers are part of the Razor syntax, and they make it possible for us to do specific tasks. In this example, this tag helper will redirect the link to the edit action in our controller. That's the role of this tag helper. There are tag helpers for different things, but basically this is the good thing about the Razor syntax, that it allows us to connect our pages to our server-side code or to our controllers. I'm going to actually use another tag helper to specify the ID of this edit page by using the ASP-route-ID at item.id. So we'll redirect us to the edit page for the specific, with the specific ID for that item. And now we get errors here because we have not created that action yet. Why did I remove it here? Edit. Okay, my mistake there. Here I'm going to use another tag helper, which works the same way, but just will redirect us to the delete page for that specific item. And this is all we'll display in our index page. I'm just going to comment this out for now because we'll get many errors. And just go back to the controller to proceed with the next action. Now, the next action we are going to create will be the action to create an item. Firstly, we just need to create a public IActionResult with the name of create. And this will just return the view, the corresponding view that we're gonna create right now. So just go to the items folder in our views folder and create a new Razor page, an empty Razor page here. I'll name it create. And just as we did in the last time, we need to import the model, not a list of models, but just model. So the name of our application dot models dot item, and we'll set the title of our page with the view data dictionary here to be create. Let's just input a header saying like create an item. And now here what we're going to do, we're going to use a form to submit the data that we'll input in the form to another action that we're going to create, so that basically we store this new item that we'll create in our database with the help of Entity Framework Core. So I'm using a form first of all here, and I'm going to need to use a tag helper to connect this to an action in our controllers named create, and we need to specify here the method to be post. We are basically going to create a second create action in our controller, which will be of post type. What this means is that this action will be able to get only post requests. So get requests are those requests when the action returns just some data from the server or a web page, and the actions that accept post requests, they are actions that retrieve data from a form submission. And inside this form here, we're gonna have some div tags for each of the properties that we'll take in this form. So let me just give a class to this div. This is just a Bootstrap class for some styling, which is named form group, which you can see in the Bootstrap documentation to make the form a bit better looking. And I'm going to set a label for the data that we'll input here, and we'll use this for attribute to connect it to the name of the item, basically. Here inside the label, I'll just name name, which is what will be displayed on the screen, the text. And underneath, we'll write an input tag, which will accept data of type text. We'll give the class of form control to make it a bit visually better. And with the ASP4 tag here, we'll connect this input to the name property of the item, so that when we input this data to our create action, this will know that this data is the name property of an item. And just like we are receiving the name in this div group here, I'll create a new one to have a label for the price here, and to also retrieve a number here in the input, and this will be connected to the price attribute. The last thing we need in the form is a button to submit the data, which will have the type submit. We'll give it a Bootstrap class to look visually better. Button primary, which gives it this blue color, and just name this button submit. And this is how our form should look like. If I run the application and go to actually this page, the form is not yet optional because this page is not yet functional because we haven't created the second action method, but we'll just see how it looks like. Let me see what error I did here. Okay, line 4. Here, I just misplaced the semicolon. Let me run the app again and go to the create page /items/create. This is how our create page looks like. We can input a name here and a price for our item, and if we hit on submit, this data should be inputted to our action method, and then where we will specify how we will store this data as an item in our database. So let's just get back to the code and go to our controller. So here we'll specify a second create action, and since this action will take post requests, we need to specify on top of the page HTTP post for get requests, for actions that receive get requests. This is not necessary to note there, to write there. So I'm gonna continue with the method, the action method here, which will also be an asynchronous method. So I'm gonna need to write the async keyword. This will return a task of IActionResult. I'll name it create. And here I'm going to need to use an attribute called bind to bind this, what we'll receive in this action, basically the ID, the name, and the price of the data that we input in the form, and to bind it to the item model so that the method recognizes that these data are part of an item. Here we need to write an if clause to basically check if the model inputted in our form is correct. So we're going to use a model state that is valid method. So this method here of the model state class just verifies if the model inputted in our form is an actual item, basically. And if this is the case, we'll use the context that items that add methods. So this method that Entity Framework course gives us, and add to the context this item. So basically the input from our form, we're adding it to the database in this line right here. We are using the await keyword here, and we'll just use the context one more time to save the changes done to the database by using the save changes async method. And after the changes are saved in the database, we just need to return the viewer to the index page. For this reason, we're going to use the redirect to action that will redirect the user to the index page. Just like we return the view, redirect to action basically is an other result type, just like view result. Redirect to action result is another result type that will redirect the user to the index page, as already mentioned with big I here. And if the model is not valid, we'll just return the user to the current view. So again, to the create page, and we'll input the item here. Let me just run the project and see how our create method, action method, is working. If I put a name for an item, let's say microphone, that price it like $200 or something, just 200, since the price accepts a number, and click submit, should be redirected to the index page. And here we see the name of the item and its price with 2 places after the comma. And basically I can just input a $sign there manually in the index page in the items folder. So just here, like a $sign. Have to reload the page here. And we should see the $sign after the price. Okay, now let's just go back to our controllers and write another action, which is going to be the edit action. In this case, we're still going to need 2 edit actions, one for the get request and one for the post request. Firstly, let's start with the action that accepts get requests. This is going to be an asynchronous action or action method, which will return a task of IActionResult. I'll name it edit, and this action will actually receive an ID. Let's open up the curly braces again, and I'm going to use an item variable to loop through the database as a search for a specific item. So basically, when we are redirected to a page with the details of a specific item with a specific ID, we will loop through the database to find that item and display it in the screen. So I'll use the await keyword here to await the result that we expect from the database. So underline context dot items that, and here we'll use the first or default async method that will search for a specific item in the database, where the ID of that item will be equal to the ID that we take here in the action parameters. And then I'm just going to return the view with that, and the view will contain that specific item. Let's just create now another view page for the edit page. I'll name it edit. And what's interesting is that the edit view page will be similar, close to identical with our create page, because it will receive a form that can be changed from the users. Let me just copy what we had from the create page here, put it in the edit view page. The only thing that we're gonna change here is the title of the page, which will be named edit. The header, I'll change it to be edit an item. And I'm going to redirect the users that submit the form to the edit action in our controller. The method is going to be a post method. And as you can see here, basically the user will be redirected to a form with already filled data, to a form to change the name of or the price of that specific item. And when a user changes the data here and submits the data of the form, the user will be redirected to the edit action, and we'll need to create the post action in our controller as well. So we need to write the HTTP post data annotation. This will be a public method. It will be asynchronous as well. It will return a task of IActionResult. I'll name it edit. And this action method will receive an ID, which will be int, and also the data from the form. And we'll use this bind attribute here as well to bind the data that will receive the ID, the name, and the price that we'll receive from the form to the specific item model. And again, we need to make this check if the model inputted is a valid model. We need to use the context here and update the database with that specific item. Then we need to use the await keyword here and save the changes to the database with the save changes async method. And then we'll redirect the user to the index page, and we'll use this redirect to action result, and we'll redirect the users to the index page. And if the model is not a correct model, basically we'll return the user to the page they already were together with, and we'll input this item to the page, so that when the user will land on the same place on the same edit page, the form will be already filled with the data. So let's just run the project here and test this in action. Let me check what I did, what kind of mistake I did there. I think I forgot to close the method here, the action method. Should be okay right now. Okay, let me just refresh the application, and I'm actually gonna go to our index page. The index page in the items folder. And I'm gonna uncomment the edit anchor tag here. So I'm just gonna comment this anchor tag that deletes the items. So I'm just pressing Ctrl K plus C to comment this part. And we should have, in the table, we should have basically a link to redirect us to an edit page for the item that we have already stored in our table. So let's just refresh the page here. Here we have the item's name, the price, and this edit anchor tag, which is basically links us to another page. The address of this link is items/edit/1, which is the ID of this actual item. And here, if I would change the name here, let's say, change it to just like Mike. I can change the price as well. If I hit on submit, we should be redirected to the home page, and the name is changed. The price is changed. So basically, when we submit the form, we call the HTTP post edit action method. Then we basically check if the data submitted is correct. We update the database with that item that is inputted there. We save the changes and we redirect the user to the index page. Now, last but not least, we'll need to create a couple of other action methods to delete the items. The first method will accept GET requests, and it will be a public and asynchronous method, which will return a task IActionResult. I'll name it delete, and this will receive in the parameters here an int ID. I'm using a variable here. I'll name it item, and we'll look through the database for that item with that specific ID. So I'll use the await here to await the data from the database, and then underline context that items that this first or default async method to search for that specific item. The item's ID that we're looking for should be equal to the ID that we are taking here from the parameter. And let's just return the view with that specific item variable that we have here. Let's just go to our items folder inside our views directory here and create one last view page. I'll name it delete. In this view page, we need to import the item model as well. So by just writing the directory of the models and the name of the specific item of the specific model, we can specify the title of our page here with this view data We'll name it like just delete. And let's just input a header here asking the user like, are you sure you want to delete this item? Question mark, question mark. And let's just input here in form of a few paragraphs the name of that item that we're receiving in this view page. We'll access the item by writing at and this modal attribute that the view page has, dot name, and I'll use another paragraph to access the price of that model. Let's just write the $sign here as well. And if the user is sure he wants to delete the model, the item that is displayed on the screen, we need to write a form for the user to be able to delete it. So form, to write the ASP action tag helper that we have been using so far to redirect the user to a delete action method that we'll create, which we haven't done yet, which will be of type post. And here we're just going to need an input to take the ID of our model, and because it's not a good practice to basically display on the screen IDs, we just put this input to be of type hidden so that we won't see the input on the screen. And by using the ASP4 tag helper, we'll connect the value in this input with the ID property. And then another input we're going to need to be of type submit. This is just like a submit button, actually. We'll give it a class, a bootstrap class of button and button danger, which makes the button red. And the value, or what will be displayed in this button or in this input, will be delete. Now, when the user clicks on this input time and submits the form, he will be redirected to the delete post action method that we will create right now. Set the data annotation of the method to be HTTP post, and the method will be public. It will be an asynchronous method to return a task of IActionResult. And this method will be good to be named delete as well, but we cannot name it delete because we already have another delete method, which in this case will contains the same parameters. So when we have two action methods that have the same name and the same amount of parameters and the same name of parameters, we cannot have these methods with the same name. For this reason, I'm just going to name it delete confirmed. As a practice, this will receive an int ID parameter, and actually, because we specified in our delete page here in our form, we specified that the form will be submitted to a delete action. The practice, a common practice to be used in this case is that inside this data annotation here, you can write the action name delete. So whenever user sends a request to a delete action of type post, this method here will receive this request. Now I'm going to need a variable here to get our specific item from the database. I will await the results and we'll get the item from the context by writing context.items, and I'm going to use the find async method. Here we'll input the ID, so we're finding the item we need with this specific ID that we get from a parameter here. And here we need to write an if clause to check if the item is actually not null. So basically, if we can find this specific item with that ID in our database, we want to remove that item from the database using the remove method, which will take the item as an argument here. Next, we just need to save the changes to our database. And as you can see, all of these methods we are accessing by using the context. And then we need to return the user to the index page. So in this case, in this action method here, even when the item is null or not, the user will be redirected to the home page, to the index page. Let me run the project one last time to check all the functionalities of our application. And before I forget, I'm just going to go to the index view page to uncomment the anchor that will redirect us to the delete page. Just hit on Control K plus U to undo the commenting here. The ID here is apparently with a lowercase letter. Let me run again the project. And let's just go to the /items/index page. Okay, here we have our only item here, the mic of a price with a price of $300. Just actually gonna create a new one, /items/create. Let's say keyboard price 100 euros, $100. Hit on submit. We have our second item here. We already saw the delete the edit option that works. If we click on submit, we'll be redirected to the index page. Let's try the delete, how it works. If I hit on delete here, we'll go to the route items/delete/1, which is the ID of this specific item. And we see here, are you sure you want to delete this item? We see the name of the item, and we should have seen the price here, but apparently something is not right there. Okay, so we need to specify here the model.price. Let's just refresh the page. Okay, we see the mic, the name of the item, the price of the item. If I click on delete, we see that we do not have this item anymore in our index page. So basically we called the action method, the delete action method in our controller. Here we found that item in our database, we removed it, we saved the changes, and we redirected the user to the index page. What is a one-to-one relationship? Let's say we have a list of items stored in our database, and we want to connect each item with a single serial number. We also want that serial number to be assigned to only one item. In this case, they need to have a one-to-one relationship. This is what we will learn in this video, and it's going to be super simple. You can see that our item has only one ID, a name, and a price. I'm just going to start by seeing here that our name property in this case has this kind of error. The properties by default are declared as non-nullable, and the compiler basically just wants to remind us that we haven't initialized the value for this property yet. Now, in some cases, we would want to add the question mark after the property type. The error would go away. But in some cases, if we would not want our property to be null, for example, so that we can skip this error, we can just give it an initial value here, like null with the exclamation mark. And basically this gives the name property a temporary null value. So just to remove this warning that the compiler gives us, we give it a temporary value where telling the compiler that we do not want our property to be null, but basically we will take care that we give it a value in the future. I hope that's not complex. And now back to our one-to-one relationship model. I'm gonna need to create a new class in our models folder. I will name this serial number. And let's give it like an ID property. As you can see, the integers and numbers usually don't take an error because by default they can be null actually. But if we'll give the serial number a name as well, and to escape this warning, we'll give it an initial value here. And now we're just going to need these two properties for the serial number alone, but now to connect it to our item with a one-to-one relationship, we're just going to need to connect it with an ID for the ID of the item. I'll write it here, item ID. And also we'll specify here that this will be connected to an item model. And I'm going to need to specify on top of this item property that the foreign key, basically how we will connect this item, this property to the actual item, is that we're going to use the item ID property. So we're using this data annotation to basically connect the item with our serial number using the item ID as a foreign key. And here I'm actually going to use the question mark on top of both of these properties because we want to make it easy for us that we do not have to connect the serial number with an item just as soon as we create this model. We can give it a value later on. We create firstly the model, let's say we create the item, and then afterwards we can connect it to a serial number and vice versa. So I'm just going to go to the models folder one more time. I'm going to go to the item model as well, and I'm going to connect it to the serial number. I'm going to need the serial number ID property and a serial number property named serial number. So basically what we're saying here is that we will connect this model with a serial number, the item model, and we're going to use the serial number ID as the foreign key basically, but we do not need to specify this data annotation in both of our models. In one of them it's enough. And I'm going to set this to be nullable as well here, so that, as I also said before, we do not have to specify the serial number ID just as soon as we create a new item model. Now that we have this clarified, let's just go to the context. I'm going to need a dbset instance for our serial number model. Serial number. I'll name it serial numbers in plural. For us to give some initial data to an item and a serial number in our database, we can use here we're going to need to override a method that Entity Framework Core provides us. So I'm just writing here protected override void, since the method won't provide anything, that on model creating. And what this on model creating does here, this is like a method that Entity Framework Core has, which takes a model builder class as a parameter, which is a class that will allow us to configure the different configurations for our models and the relationships with them. So actually by default there exists an on-model creating class in Entity Framework Core that configures our items, our models, and the relationship between them by default, but now we are overriding it to specify either the data for our models when they are initialized or the relationship between them. So just inside this method here, what we're going to do is I'm going to use the model builder parameter, which was this class that we'll use to add configurations. And I'm going to write that entity. I'm going to write for the item first. So I'm just going to use a method has data here. Just a model has data here to give some data for a model, basically to create a model in our database for the item. How we can do this is I just need to write here new item. And I can, let's say, specify the ID to be like 4. I don't know, it's a number. I don't know if I have an ID with an ID of 1 in my database. The ID is an integer, so no double quotations are needed. The name of our item, I'll set it like a microphone, I don't know, some item. And now I'm gonna add the serial number ID. Do I have a price for the items? I think I do. Okay, I'll set the price to be, I don't know, price to be $40 or something. And the serial number ID, which will be the ID of the serial number, is I'll input like a number here, like 10, and then I'll need to create a serial number with the ID of 10, so that these two models will be created. Just like I created an item in our database, I'm going to create a serial number as well. So I'm just going to need to write here serial number. We're creating a new serial number. I'll use the ID of 10, so that the first item will be connected to our serial number. I'll name it like, the name was a string, I guess, so I'll name it like Ike, like 150 or something, just some code that just what could represent a serial number actually. And now I think the only property left is the item ID, which I'll set it equal to 4 so that it will be connected to our first item. After we have created two models in our database, we have the database instances here for the models tables to be created in our database. I'm just going to need to go to Package Manager console and add the migrations. So add migration. I'm just writing here 1-to-1 so that we know for this migration we edit a 1-to-1 relationship in our database. You can name it whatever. Hit on enter. Okay, now we just need to update these migrations, this database schema that was created here to the database. Everything seems to be done correctly. Now, so that we show this on the screen, actually, I'm just going to go to our context, to our index page. And when we load the items from our context, we need to specify here that we want to access the serial numbers as well. We just gonna need to write an include method after writing context.items, after accessing items in our context. And after writing here include, just gonna need to get the variable here and access with it the serial number. Now that we can have access to the serial numbers from our items, we can go to the index page and also display the serial number in a column. So here, like in the table header, just write here serial number, and we'll access it from the database here by just writing item dot serial number dot name of the serial number. We can just run our application now and go to the index page. Let's go here to /index /items, the name of the controller, /index. Now we're getting an error here while processing this in our index page, and the error is actually happening because we have specified this serial number in the item that it could be null. For us to avoid this, we can just give a question mark after accessing the serial number here from the database, and in case it is null, nothing will be displayed in that column. If not, we'll access the name of the serial number. Let me just run the application one more time. And here we should see a microphone priced $40 and the serial number is mic 150. So we have connected a microphone with a one-to-one relationship with a serial number and actually vice versa as well. And if we would try to, we cannot connect this serial number with another item actually. Even if we would try to do this either in the context or in our database, this would give us an error. And the first item actually here, we haven't connected it to a serial number yet. That's why this column is empty for the moment. Let's say we have a list of items stored in our database and we want each item to belong to a single category. In this case, one category can be assigned to many items, but each item can belong to only one category. This requires a one-to-many relationship between the category and the items. In this video, we'll learn exactly how to set this up, but don't worry, it's not that complicated. We'll connect our models to each other, make the necessary changes in our action methods, and then see how it looks on the front end. So let's get back to the project. And let's go back to the item model as our main model, and we can actually connect this to like a category. And a category is like a one-to-many relationship model with the item, but from the category's side. So a category, let's say electronics, books, or something like that, can have multiple items be part of it, but a specific item can be part only of one category. So how we can write this relationship? Let's just go to the models folder and add a new class. Let's name it category. And I will give it normally an int ID property, a name for the name of the category. And I'll initialize it so that we skip the warning that the compiler gives us. So giving it like an initial value and telling the compiler we'll set a value to this name later. And then we can connect this, we should connect this with a list of items. I'll name it items. And I will make this property to be nullable with the question mark so that when we firstly create a new category, for example, we do not need to connect it with an item right away. We can add this later on. So one category can have multiple items, but if we go back to the items model, one item can have only one category. So I'm going to need a public int ID property, not int ID, but let's say category ID, and a public category named category. Let's specify the foreign key here so that our category will be connected, our item will be connected with the category model by using the category ID property as a foreign key. And I'm gonna make both of these properties as nullable so that if we have created a new item, we do not need to specify the category right away. Now that we have specified how this relationship looks in our model classes, I'm gonna go to the context and add a dbset instance for us to be able to store this category model in our database as a model instance. So I'll write here category, name it categories in plural as a practice. And I'm going to create manually 2 categories in our database. So I'll use this model builder class as well, that entity that category that has data method. And just write here a new category. Let's say an ID of 1 and the name of, let's say firstly electronics. And I'm just not gonna connect this with an item right now. We're gonna set it up in our action method so that we can do it, let's say, interactively in our application. And like a new category as well would be okay. I'll give it the ID of 2 and I'll name it, let's say, something else like books. Now I'm just gonna add the migration firstly to the database, and then we'll handle our action methods. So just add migration one-to-many. Let's name this migration. And then just gonna update the database. Okay, the first thing I'm gonna do is go to the items controller. Let's start with the index action method. We're gonna need to include the categories when we search for the items in our context. So I'm just gonna place this a bit below in one line so that we can see everything better. So I'm just gonna write this .include method again, give it a variable like C, and just include the category when we search for the items in our database so that this is included as well. But now that we haven't connected actually any of our items with any categories, so we're going to need to set it up in our create page so that you know when you create like an object, you will have an option. Let's say when you create the item, you'll have the option to select one of the default categories. For this reason, we are going to need to display all of the categories that we have in our database in the create page. How we can do this? We're going to use the view data dictionary that we can use in ASP.NET Core. I'll name it here. We'll give it a name here of like categories. And here we'll give a select list to this view data. What this select list will contain, we'll loop through the context to get the categories, and we'll search them by the ID. And we'll basically say here that we'll display them by their names. So we'll get the ID and the name of these categories from looping it through the database. And this list that will be created here, will give it into our view data dictionary. We're going to need to write this using directive on top of our page. This using Microsoft.ASP.NET Core.MVC.rendering, which basically is the directory that includes this class, the class for our select list. And now we have basically have a view data dictionary passed to our create page that we can use in our create view page. Let's go to our create view page here. And how we will access this, I'm going to need another div here, a form here for the user to be able to input a category when they create the items. So the label will be for the category ID. Let's say category here as the label for this form. And actually we are gonna need to use here like a select HTML tag. Here we need to specify this tag helper ASP4 to connect this to the category ID property. And in the ASP items tag helper, here we're gonna need to include basically what we take from our view data dictionary. We can do this by writing viewBag.categories, which was the name of our view data, and the viewBag is actually the class, just like a dictionary that we use to take this data that we have from our controller and display it here on the view pages. So this is as well another class, and I'm just going to give a class to our select list here of form control. And this is it with the view page. What we should write in our view page. If we go back to the controller, now if we go to the post action method, we need to bind here the category ID that we'll take from that select list as well. And we could leave it as it is now, but we can do the same thing and modify the edit page as well, so that for the items where we haven't specified the category, we can edit them later. So I'm going to need this view data dictionary here to input in the edit method, in the edit action method. In the post method, we can include then the category ID, just the same way we did with our create method. And we are going to need to modify the edit view page by just giving it this line, this div group here for the list that we had from the create page. Let's input it in the edit view page. Just the same thing. So we're inputting like a form for us to modify the category as well. And if I run the application, let's just see how we can create an item with a category from the list of categories we have in our database, and how we can edit it for maybe the items where we didn't input a category. So if I just refresh here, let's go to the create page. Okay, so we have probably made like a typing mistake somewhere. This select text, I forgot an E. Select here as well. And let's just update it in the edit page as well. Okay, let me run the application one more time. Here we see in the category input here, we have a list of both of the categories that we have written in our database. So we can select either electronics or books. Since we have a books category, let me write a name for a book. Let's say tech book, like C# book. Let me give a price to it, like $20. The category is books. Let me submit it. We should be redirected to the index page. A C# book was created here. We had the price. We didn't give it a serial number, but we forgot to write a column for the categories actually. So let me go back to the project, to the index view page. Okay, just another column header here for the category. And down below as well to get the value of the category for each item. So item dot category dot name. We can input the question mark here. If it's null, we'll display nothing. Let me run the application one last time. At least I hope one last time. Okay, so we see here in the category column here, we see that for the item that we created, we see the books, the category. Now, since we changed the edit action method and the edit view page, we can basically edit these two other items to have a category as well. So if I go back to the first item and click on edit, we can input a category to the first item, click submit. And the keyboard now has an electronics category. Let's go to the microphone item. I'll leave it as electronics as well. Click on submit. So we changed the category for these two items as well. So the electronics category is connected to two items in this case. Let's say we have clients and items in our database. Each client can have multiple items, and each item can be bought by multiple clients. This creates a many-to-many relationship that we need to manage with a helper model. In this video, we'll cover how to set up the models, configure the relationships in the database, and make the necessary adjustments in our application. So let's just go back to our project, and our main model was the item model. Now, if we connect the item with a client model, let's say one item can be purchased by multiple clients, and one client may purchase multiple items as well. So this is a many-to-many relationship between the item and the client. Unlike the other relationships we've seen before, this type of relationship requires an additional helper model to connect these two models with one another, which we'll see in a bit. But firstly, let's just create a client model by just going to the models folder and adding a class for the client. And firstly, we'll just give it a public int ID property and a string name property. We'll initialize this property here to avoid the compiler warnings. And now, as I already said, we're going to need a helper model. So this client model will be firstly connected to this helper model in order then to be connected to the item model. We'll see this better after we create this helper model, which usually takes a combination of the names of the two original models. We can name this item client. And this model will be connected to both the client and to the item. For this reason, we are going to need firstly a public int item ID property to connect to the item, and of course an item property named item. So basically, using the item ID, this item client model will be connected to an item model. And the same thing will happen also for the client model. So we need a client ID property. And a client property named client. So that basically what we're telling the item client here is that the item client model will be connected to the item and to the client using these foreign keys respectively. So the item ID for the item and the client ID for the client model. And in each of the other two models, we need to connect these two models with this helper model. And basically we need to have here a list property, a list of item clients, to connect our model with multiple item clients. I'll name it item clients as well. And I'll make this property nullable so that we do not have to assign a client firstly as soon as we create the item or as soon as we can create the client of that. And I'm going to copy this property and paste it in our client model as well. So basically the client here and the item as well are firstly connected with the item client, which then connects them to the specific item in this case, for example, in the case of the client. And now what we need to do is go to our context class and actually add these dbset instances of the two new models we created so that they will be stored as tables in our database. So public dbset client, I'll name it client, and also a dbset instance for our helper model. Named item clients. And unlike the other relationships, actually, we are going to need to specify this relationship of the item and the clients with the item clients model in our context as well. So just somewhere inside this onModel creating method, we'll basically firstly use the model builder class to specify the relationship of the item client model or entity with the item and the client. Basically here we'll firstly specify the foreign keys that are in this model. So item client we need to write here. that has key. So here we specify both of the foreign keys. Let's take a variable here, item client. We need to write the new keyword, and inside curly braces, then here we will specify the two foreign keys. So the item ID and the client ID. And in another line, then we will basically specify the relationship that this item client model has with each of the two models. So here we specified the keys. Firstly, the foreign keys. Here we'll specify the relationship in a bit more detail. So we need to use the model builder class again. That entity item client. So we basically say here that the item client entity is connected to the item model first. To the item model. And we write the with many method that specifies that an item can be connected to multiple item clients model. And we specify the foreign key again, which will be the item ID. And we'll copy, I'm just going to copy this line and do the same thing for the second relationship between the item client and the client model. So we just need to change here the relationship so it's connected to a client model with multiple, which is connected with multiple item clients, and the foreign key here will be the client ID. And that was it for our configurations in our DB context about the relationship between our three models. Now let's go to Package Manager console. Let me make this bigger and add another migration for the many-to-many relationship. I'll name it just many-to-many, the name of the migration. And the database schema or the migration was created. Now let's just update the database. So all of the changes we made in our project will be reflected in our database as well. Everything was built successfully. So now for this video, I'm gonna go and see the database, and we're gonna populate the data in the database. So I'm just gonna go to the database that I connected with this application. Let me refresh it. If we go to tables, okay, I'm just firstly gonna go to the items table and click on edit top 200 rows so that we see the top 200 rows. Okay, let me just see the clients table, edit top 200 rows as well, and the item clients model. Okay, so what I'm gonna do here, let me just firstly create two clients, one with a name, let's say Zach, and one with the name like Martin. So we have two clients with the ID of 1 and 2. Let me just find our items here. So our items, we have an item with the ID of 2, one with the ID of 4, and one with the ID of 102, 1002 actually. So I'm gonna connect in the item clients table here. I'm gonna connect the item with the ID of, I think, 2 with Zach here, which was a client with ID of 1, and the item with the ID of 4 with Martin, and the other item had the ID of 1002, and I'll connect it with Zach as well. So Zach here has purchased 2 items, so to say. Okay, now that we have set up some data in our database, let's go to the project. I'm going to need to go to the index action method in our controller, actually, so that we include here when we query the items in our database, we want it to basically include also the list of clients with which an item is connected to. So here I'm going to add a new line and click on include. I see that item clients. And then in this case, in a many-to-many relationship model, we need then the then include method. So basically, after we include here the item client helper model, with which the item is connected, then we need to include with this then include method the client's model, because the item firstly is connected to the helper model, to the item client's model, and then it is connected to the client's model. I hope that's not too complicated. To the client. Okay, now I'm just going to need to go to the index page, to the index view page, and add a new table header here for the clients. And down below where we display the list of clients with which a model is connected to, I'm just going to use this table data tag here, and I'm actually going to use a foreach loop because one item may have multiple clients. Here we'll loop through a variable. I'll name it client in item clients, which is here. This was the temporary variable we created, and we'll loop through each item's item clients. Then we will display the clients name. So we are accessing for each item the item client's helper model, and then the client.name property of that model. Let me just run the application. Let's refresh the items route. We should see another column in our table, and we see for each item we see the client. So for the keyboard we see that the client is Zach, for the microphone is Martin, and for the book is Zach again. So basically in this case each item has only one client, but the client has two items. And this is basically how the many-to-many relationship works in ASP.NET Core MVC. If this video was helpful, YouTube thinks you should watch the video that's now appearing on the screen, so I'll see you there. Don't forget to hit the like and subscribe buttons for more content like this, and I'll see you soon.